Sir has joined. Technical team, please make co-host to Mishra sir.
Good morning.
Good morning,
Good
sir.
morning, sir. Good morning.
Good morning. Good morning. Good morning.
Gaurav, it's 10:30. We can start.
Okay, okay, thank you.
Just wait for 1 minute.
Sure, sir. Sure.
Okay. Shall we start, sir?
1 minute. 1 minute. Okay, you can do now.
Okay, thank you so much. The constellations of academicians, Your Excellency, invited keynote speakers Dr. D.K. Mishra, Chairman ACM Indore, STTP Patron Mr. Gauravji Sujatia, and Dr. M.K. Dubey sir, Member of Advisory Committee Dr. S.C. Sharma sir, Director AITR, and Dr. Kamal Sethi sir, Head CSE Department, STTP Coordinator Dr. Shilpa Bhalera, Head CSIT Department, Dr. Geeta Santosh, Head ST Department, delegates and participants from various institutions. Good morning, everyone, and welcome to the third day of STTP4 on Data Science Unfolding Layers of Knowledge under the AICTE Quality Improvement Scheme, that is AQIS. This program is conducted under the banner of Computer Society of India and ACM chapter at AITR. I, Gaurav Mandloy, will be your host for the day. Congratulations on coming so far in the program. It won't be wrong to call you all masters of data now. Acropolis Group is the outcome of heart and dream, a manifestation seen by passionate eyes and vision to be the topmost institute in India by the Sujatia family. The Acropolis Group has achieved phenomenal success over the years, which has been due to our Honorable Group Chairman mantra of enlightening wisdom through quality and innovation. Over the years, the Acropolis Institute of the Technology and Research has acquired unique position of pride in the technical education system in Indore as well as in the central India under the leadership of our Honorable Vice Chairman Sir Professor M.K. Dubey and our Honorable Director Sir Dr. S.C. Sharma. I request technical team to play the video of Acro Anthem.
We're walking with the burden to enlighten all, spreading the ray of wisdom and you all, focusing on winning blocks of the road, follow and lead us who made us to roll. Acropolians, we are the Acropolians. 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 Climbing the peak to the spa, starting with the thrust and leaving a trail for the world. By overcoming the challenges in the tough passages, we have kept our head held high. Acropolians, we are the Acropolians. On a journey to the stars, we are the Acropolians. Converting dreams into a vision scene. Showering wisdom wherever be. Creating a winning zone everywhere. And crowning ourselves with a golden name. Acropolians, we are the Acropolians. Acropolians, we are the Acropolians. Acropolians, we are the Acropolians. Acropolians, we are the Acropolians.
Thank you, technical team. The last 2 days of the event were amazing and full of learning. I appreciate your will to continue with us and mark your presence to make today a productive affair. Today's first session will be addressed by our very well-known guest speaker, Dr. D.K. Mishra sir, Director Sri Aurobindo Institute of Technology and Chairman SCM Indore. So, without further ado, I would like to request Dr. Asif Ali, Associate Professor IT Department, to introduce our eminent speaker. Over to you, Asif sir.
Thank you, Gaurav sir. Just I'm sharing my screen.
Okay.
My screen is visible.
Yes, sir. Yes, sir.
Good morning, one and all. It's my immense pleasure to introduce and welcome our honorable guest, Dr. Durgesh Kumar Mishra sir, Professor CSE, Director Microsoft Innovation Cell, Sri Aurobindo Institute of Technology, Indore, Chairman SEM Indore, tell about its experience. He is having more than 24 years experience in the academic as well as 10 years experience in the more than 10 years experience in the research. His research area are database SQL, PLSQL, programming, data mining, big data, computational security and privacy, compiler design, principle of programming. He has published more than 90 papers in the referral journals, international journals, national conferences, IEEE, ACM conferences, etc. He has also published various books, including database management systems. Tell about six awards and achievements. He has many achievements awarded with best paper award, presented award at international level by the CSI. If we talk about his career, he is done MTech degree in computer science from DAVV, PhD degree in computer science. Senior member, he is also having various positions in his careers. Senior member of IEEE, held the position chairman IEEE MP section 2011-12, chairman IEEE Computer Society Bombay chapter 2009-2010, chairman CSI division for communication at level 2014 to 16, and he is visited various places to deliver his tasks, including Taiwan, Bangladesh, Singapore, Nepal, USA, and UK finance, and many more. To tell about your experience in few words, it's as difficult as to find out a pearl into this sea. Sir, this is about just a glimpse of your experience. I, Asif Ali, on the behalf of Acropolis, all family, I welcome you, sir. And sir, it's my pleasure to welcome you, and also thank you, sir, to grace us. Thank you very much, sir.
Thank you, Asif, for the introduction. Again today. Okay, and I think you're have changed a lot of things. Good. Thank you. Thank you to the organizer for inviting me again. Okay. Yesterday we first of all I'll check to share my screen. Okay, it's possible. Okay. Yesterday we finished about something the Python hands-on on computer vision, and 2 or 3 things I have missed. I think I'll try to finish first, and then we'll start the face recognitions. Okay, I think I will recall it, and I think we did a lot of things here. It's visible. Screen is visible.
Yes, sir.
Okay.
Yes,
Okay.
sir, visible.
Okay. This we did this all this how to convert the image into the blur and the canny, and what the use of the canny images in the computer visions, and how to resize, and because we required something this type of things in the face recognitions. Okay, these are how to draw the line, how to draw the circle, how to put the text on the image we already seen, and how to create the image with the numpy with this np.zeros. You can create the image with the numpy and can draw the image. We have yesterday we seen already. I'll just run it, then you can recall it. Okay, how to run this. Okay, you can see the image, how we can draw this. This is the numpy image. Image is a black image with all the numbers are zeros, and how to draw this arrowed line, how to draw this normal line, how to design the triangle, how to design circle, all this thing. We can design any type of object over the image. That's why I show all these things. You can write some text also, right? And we can play the video, we can play the audio, and we can mix up of all these things, right? This is the possible. And this is again, I am going to show something. This suppose how to write how to capture the video from the camera, and how to put the text on that. I think we did yesterday. Now there is an important thing, how to create the functions, that is the event, how to create the event over the over this image. So this is what we can see here. This I have created one function, that is a click event. Perform the click event. I will show you quickly, and then we'll shift to the face recognitions. Right, this event is left button, right button, like our this programming languages we are doing is the right button and left button. We can use this, we can capture this event and show something. Here I have used these 2 events. This event is a left button event. Okay, this left event button, I have to put something like this is string. When to put it, there's x and y coordinators of that particular location, because we have to find out the x and y coordinators coordinates of during this face recognitions. So in this event, when you press the left key, then x and y coordinates will be displayed there. And this second event is the right button down event. Right button down event, you can see this when you click this right button down event, then I have designed for that how this color will be displayed on the screen. What type of color is there? BGR. What's the value of the BGR color is there, right? This is what I have created here. Now this we use the 2 libraries. This is import OpenCV2, and there is a NumPy. This NumPy library I have used because we have to draw this some images on the basis of that. This definition, this function, this is a function, nothing but this is def is a function. I have created one function, this is a click event. Now these are the click event. This is known as callback functions. These callback functions are called here, right? This will what the image, the program will start here. This image, you can read the image. This image is what something image is there. This 7people.jpg is there. This yesterday we already discussed about that, how to read the image from the folder. Okay, then I have to show the image. After that, show the image. We can call this how to call this mouse callback function. This callback function, that is set mouse callback, that is a property is there. With the help of that, we can call the function. That function is click event. This click event is a function. This callback function we define already here. This definition is a click event. Okay, so this on the basis of that, when you call the click event, when you press left button and the right button, it will perform some actions. This action is what first in the case of this we have received this, because this function is having what, one is the event name, these parameters are there, is another is x and y coordinate. It will we can check here, it will return, and then flag it's true or false, and then some parameters are required for other purpose. Okay, so we are going to capture this x and y values of that. Okay, event, there's one event is what, left button press. Then event, if event is the left button, then what we want to do, okay, we want to do is to get the x and y value. X and y value convert into the string. And yesterday we see already that how to put the text on the screen, how to put the text on the image. This image put text is image string xyz xy. This is a font, what the font is there, this font name is here, and this string is what, having x and y value. Okay, and this is what the color is, a 255. This is a BGR, blue, green and red. Okay, combinations in the event. When the second, if the event is this when you call the event click event, the second event, if you press the right button, then blue, green and red, I have captured these three values, blue, green, and this image is what, y and x, and 0 is what, gray, 1 2, these are different channels are there. We can capture this for the this BGR. For blue we can use 0, for green we can use 1, for red we can use 2. These are coordinates of okay, right, we can see it. Okay, for this I have to use I'll run it. You can see this is the image. When you press the left button, it will give the coordinate of this. This is the left button, this is 606 and this something. When you put the left button, it will give the coordinate of something. Okay, this is the image. When you put the right button, it will give the color. Color is what, 172, 188, 253. This is a special color. This is required in the computer vision. Sometimes we have to capture the color of the particular pixel and to copy to the all other portions, so that this is the color, this is BGR color we are, this is 166, 169, and this is the black, this is what towards the black, this is a 40, 35, otherwise it's a 0, 0, 0. Complete black is a 0, 0. Maybe these hairs are maybe the 0, 0, 0, not, it's not 9, 10 and 36. Okay, it's complete not black is there. Okay, this is what another darky, this 675. Okay, if this is white, it goes to 255, 255 something. This is 172, 177. It's not a complete white. So that this is what I want to say. This is the left and right click event we can perform on that, and with the help of this we can get the color as well as the location x and y positions. And we required in the some time to read the faces. You require the faces. We have to find out this face. We have to put the triangle on the face, so that we can identify this face. This is a face. Our classifier in the face detection will classify the face and then recognize it and give the results. Okay, so we required all this thing here, so that this is required in the case of if we do this something. Right, this is over. You can see this is the coordinates. You can find out when you click that coordinate will display here in the output. Okay, this I am read on, this is event. Okay, I'll just finish it some points, because this is a 4 days workshop. I am doing this on the computer vision, and this I am showing you the little bit about something what is the important for the face recognitions. This is what I can show you. This is the image. Okay, I can run it. This is a massive image. Is that we want to check the size, type, this is a shape, size, and D type, and we can extract this color from that particular shape. Okay, you can just run it. You can see this is the image is there. Okay, now how I can transfer this object to the other place, that is again very important. So that we have to find out the coordinate of this. Suppose I want to transfer this ball to this place, how to transfer this ball, that is very important. Now this you can see the size, you can see what print image shape. This is what shape is size is what 342, 548, and 3 is the channel, means is a color image. Okay, and the size is this 5 6 something bits. Okay, and then data type is unit 8, means unit 8. We have create the black image with the help of numpy with unit 8 only. Then all the images are basically unit 8 type. How to split the image, you can see here. You can see this is the ball. I can check the ball, pick the ball, and put the ball is here. Okay, so how it is possible? You can see this. You can see this is what, nothing, this is the image. We have to split this image with the BGR. We have written the BGR color here, and image. This we can again merge. Okay, forget about these two lines. Then this ball is this particular we can find out the coordinates. We already seen that in the last cell, how to get the coordinate of particular locations. So I have already calculated this coordinate of this particular ball from the beginning location and the end locations, so that we can extract the image. This is the extracting the image. We can extract the image with this. This image is uh, this is the image. Just wait. Right, sorry, I have muted for a few minutes. There is urgent call. So that this is what image we can extract the image with this particular location 280, 340, and 330. I have got the point from here with the help of the previous program what we did it. So this ball is I have to capture, and I have to put this image, this ball image in the different location. Different location is these locations. Okay, so sometimes we require to embed these two images, and how to embed this image, that's one example. Okay, so this is what we are doing here, and this is what how to embed two images. We have the two images, Messi images and OpenCV logo image. I want to put this logo in the backend into the Messi image. Okay, so the two image I have extracted with the help of IAMRead function. We discussed yesterday very well. And then we have to resize, because this when there is a different methods are there in the computer vision, that is what how to embed this two image when there is a one same size or the different size. For the same size is very easy to convert into the same size, and for the different size we have to measure the scale. We have to scale all these things, right? Then first what I did it is this what this convert into the same size with the help of resize. We already discussed about that. That is a resize 512, and the destination image is what, the image cv2 dot add. We have to add it, and dot add, it will give what, the two images, right? So that I will just put the hash here. Okay, and then this is what hash. Okay, right, then I'll show you this all these three images. And right, this is a one image. Okay, this is the mixed image. This is another image, is OpenCV image. Okay, that is the image 1, and this is image 2, and this third one image is, we have to add this 2 image, and this OpenCV image is there in the front. Both are the images are having the equal weightage. If you want to change the weight of this, means the this if you want to convert, if you want to put the weight of this OpenCV is the low, means it's some gray type or some dilute image is there, and this messy image will come in the front, so that we can use another function like this. This another function is this is add weighted. Okay, we can add the weight. Add, this is CV2 dot. In the previous case, we already add 2 images. Okay, so that equal weight is there. If you want to add different weight in the different images, then we can use this add weighted. That is the image. That is the first image. Image 1 is a messy. This is IMG is a messy image. I have put the weight is 0.7. We have to put the complete weight is 1. That is 0.7. This is a 0.7, and the second image is having a weight of this 0.3. Okay, so this second image will be little bit light. Okay, and this is what the aspect ratio of this. Okay, so this is what the three images. I will show you this. Then we have to show this CV2 dot this weighted image. Okay, I'll run it, and you can see these are the 2 image. This is the normal, we have to add it, and this is what the weight. You can see this is the weight of this OpenCV logo is very low. In this case, both are having the equal. Okay, so we can increase or we can decrease this, or this, suppose this is 0.3, I can increase to 0.2, decrease to the 0.1 or 0.1, and this is what 0.8 or 9 something. So you can see the different image look likes. You can see this image. You can see this image. This having this image is what OpenCV is looking in the background. Okay, right? So that we can define that add. Okay, this is one type of computer vision techniques to add 2 images. Number of times we required to merge and add 2 images. So this is what we have given the weight to the image, and then we can club it. This is one method. There is a number of methods are there. We are not having the time to discuss here. And then this some bitwise operations also we can perform. We can perform on the image. That is what something that is a bitwise and or, and then we can perform the AND operation on the 2 image. We can perform the OR operation. We can perform the XOR operation on these 2 images. These XOR not operations on that, so that it will I can run it directly. Okay, and I will show you. These are the 2 images. This white image, and you can see there are these 2 images are there. One image, and this is the one image, and this is second image. This is the bitwise AND, means both are white and black, right? This, so that this image will become here, and this is bitwise OR, so that you can see the image effect, bitwise OR image effect. So this is required in the sometime in the computer vision. So this is the exercise I have created for you. So many things are there. Now I think this is what sometime how you know how to play with the image. So I'll try to maybe possible you'll get something how to use the computer, how to use Python, how to do the programming in the Python for the computer visions. So I'll shift to my talk to this face recognitions. I'll take something. Okay, so I'll start something. We'll take a quick theory part of that, and then we'll go for the practical part. Okay, so this is what If you have any questions, you can ask quickly for the 2 minutes.
Participants, if you have any doubt or query, then you may write in chat.
Or you can open your mic also, you can. About the computer vision, if you have any doubt. No doubt.
Yes, sir. I think you have cleared all things. So there is no doubt and there is no question in chat.
Okay. It's good if there is no questions. Okay. Now we'll come to the face recognition and then we'll do the hands-on after that. I'll give the quick, I think we already.
Sir, I think one question in chat.
Yeah.
Sir, where to learn this programming?
Pardon?
Sir, where to learn this programming? Any book or website to learn?
Right, there is a very important question. The nowadays a lot of open source are available on the net, or there is some books. There is one book is also available in the computer vision, but these online books are available. Just to find out this Python computer vision with Python, you can get 2 or 3 books. I have already downloaded 2 or 3 books. If you require, then I'll share with you, and I'll share this my PPT also, so you can do that. Okay. So mostly use the internet, and that is internet is having a good library. Okay, you can just check there.
Thank you, sir.
Okay. Now, if you talk about the face detection and recognition, that is a very important topic for the today's scenario, and for the security purpose also we can use it. For the computer vision, we can use the face detections. For the data science, we can use the face detection. Data science is plays a very important role to capture the video and all this thing and to analyze all these things, right? So in this the face detection, that this I'm just quick that review in the half an hour because already 11. Okay, the face detections, we'll discuss about what is the face detection and what is the importance of the face detections, face recognitions, how to do that, right? Nowadays introductions, the everyday actions are increasingly being handled electronically instead of the pencil and pen and face to face. Definitely then we required what sometime we required our banks, and a bank is required what the digital, all these things. For the authentication they are using what the fingerprint, their authentication they are using the password and all these things. Or in the bank itself there is no authentication of the fingerprint and the face recognitions. But if because touchless we cannot go during this pandemic also, if because of this COVID, we are not able to go there in the ATM and put the fingerprint and then get the money. So at that time what we required, sometime if there is some face recognition system is there in the ATM, so that it will be very easy for that. So, and somebody, if your card is missed and somebody will catch your pin and your data, but there is cyber security, the cyber hack, cyber crime is there. They are taking your credentials, and they will take the money from your account. If face recognition technology is there, so that there is no need of what there is no need of it, because nobody is what the face is what a unique for all this thing, and without your presence nobody can open all these things. So this is a face recognition system is very important nowadays, okay, to handle your money, to handle your other things, okay, to privacy and all these things. So nowadays the biometrics is the unique. Biometrics can measure both the physiological and the behavioral characteristics. These physiological characteristics are what the physically your change, your face, and something behavioral, if you are changing your hairstyle or some things, so that how we can handle all these things. The biometrics based is measurement and the data driven derived from the action, that is a behavioral. But in the physiological, the biometrics is based on the measurement and the data derived from direct measurement of the part of the human body. That is what we can do that. This is biometrics. This is a type of biometrics, is a physiological, is a finger scan, facial recognition, iris scan, retina scan, and hands scan. But behavioral is a voice scan, signature scan, and keystroke scan. We can handle the keystroke. That is keystroke dynamics. That is a behavioral. We can capture all these things. This is what what is the face detection? Given an image, tell whether is any human face. If there is, where it is and where they are. Maybe possible this one image is having, this is a clear image, this is a blur, and then blur, this is the most blur image. Okay, but in this case you can see the five faces are there. Then we have to check whether there is a face is there or not, where is the face, and how many faces are the images. Then we have to calculate all these things, right? This you can see there's a different angle of this image is there. Even then you have to identify, then we can do that. And this is also again a very big topic. Today's I have used the frontal face detections. If the faces are in the front side, in the front face is there, we can detect it, and we can detect, and then we can recognize, and all these things we can do that. Okay, so this is what in the face detections. And importance of face detection is the first step for any automatic face recognition system. This is the first step. This is a face detection. And first step in the many human computer interaction system is expression recognitions, cognitive state, emotional state recognition is there. And first step in the many surveillance systems. Tracking a face is highly non-rigid object. Okay, the step towards automatic target recognition or generic object detection is video coding is also required. Something you can see in the this traffic signals. You can see there is some camera are there. That camera are capturing your vehicle and all these things, and they can identify that which type of vehicle is there, who is moving there. They can identify their faces also. And if put the faces, then immediately they can catch whether this is the right person or wrong person. Something there is a lot of work is going on. And in Indore, we have to check all these things, how to implement this. This is what actually, this is nothing but we already seen that this is what the video is nothing but this is the number of frames are there in the per second. You can see that in the per second more than 15 frames are there in the black and white image. In the black and white image, if the color image, there is a different size of the frames are there in the per minutes. Okay, so 95% of accuracy you can find out. Detection of faces is faster than the detection of ages. You know, earlier the this detection of age is again there is another method to detect and all these things. Side view face detection remains to be difficult. The side view face detection not difficult now. It's again there is a lot of algorithms are available in the Python is having a lot of algorithms. There is OpenCV. OpenCV is having this OpenCV library is a very good library where we can do all these things. This OpenCV is having all classifier, all face detection algorithms are available, and you can design, you can modify your algorithm. You can modify the algorithms and you can discuss it. Okay, right? So right. So this is what the current state is there. Now the challenges is what out of plane. If you see that the challenges is the frontal face 45-degree movement, the profile upside downside, presence of beard and mistake and glasses, etc. These are the challenges. If they are present, then how to recognize that. And the facial expressions, closing off by long hair, okay, hand. These are what if change. These are the behavioral changes in the face. Okay, in plane rotation, the image condition, size, Lightning condition is very important in the case of face recognitions. In the first in computer vision we discussed about that how to recognize an object. That is what the light is very important. If light is put on the object, then we can see that object. If more lights are in the background than the front light, so that's very difficult to identify the object in the even the face also. And distortion, if distortion is there, noise is there, compressions is there, so that is what image condition is very important to recognize the face. So that we have to take care of all these measures during the face recognition systems. If this is possible, this is the worst case. If all these things possible, then how we can identify, how we can remove all these things and get the exact face, okay, so that we can compare it, right? These are the different approaches. There's a knowledge based method, feature event approaches, and template matching, and experience based methods. In the knowledge base, we can define the rules. There is encoded with the constitution and typical face example relationship between the facial features. And the invariant approaches aim to find the structure feature of the face that exists even when the pose, viewpoints, or lightening condition is very good. That and the template matching is very used, and then it uses in the uh, previous algorithms several standard patterns stored that describe the face as a whole on the facial features separately. The appearance based is the methods are learned from the set of training image, what we will do here, and the training image that capture and represent the variability of the faces, okay. So this is what we are doing, this knowledge base. This is a top down approach, represent a face using the set of human coded rules. An example, the center part of the face has a uniform intensity, and the difference between the average intensity values of the center part and the upper part is significant. A face often appears with two eyes that are symmetric to each other's, a nose and the mouth. We have to check there and use these rules to guide the search process, right? So this is what the knowledge based method. Level 1 is the lowest resolutions. Apply the rule. The center part of the face has the 4 cells with the basically uniform intensity to search the conditions. Then the level 2 is the local histogram equalization followed by the age equalization. This may search by the eyes, mouth, and these validations, okay. These pros and cons of the methods of the knowledge base is easy to come up with the simple rules. This is easy to come up with simple rules because we know the face structure. Based on the coded rules, facial features and an input image are extracted first, and the face conditions are identified. Work well for face localization and uncultured background. The cons are difficult to translate the human knowledge into the rules precisely. Detailed rule fails to detect the face, and it's difficult to expand the approach the face detected different poses, and impossible to enumerate the possible cases. This is what something. This, if you talk about the feature based, the pros and the features are invariant to the pose and oriented changes, but in the cons, it's difficult to locate the facial features due to several corruption, emulation, noise, and something there is difficult to detect the features of the complex background is there in the case of feature based. In the case of template, this is store a template predefined based on the ages or regions, right? These templates are hand coded, not learned. That's the problem is there. Use correlation to the locate the faces. Okay, these pros are simple, but cons are template need to be initialized near the face image. Difficult to enumerate templates for different poses. Similar to the knowledge based method. These are what the appearance based. We are using the appearance based methods. And this appearance based methods depends on a set of delicate training face image. We will train the face, we will capture the face and train to find out the face model. And then after creating the model, the approach base is better than other ways to performance. In this general appearance based methods really on techniques for statistical analysis and the machine learning to find out the relevant characteristics of the face image. And we will do that. We will apply the machine learning for the face recognition characteristics. This method is also used in the feature extraction of the face recognitions. You know, genuine face based method is also there. In the genuine face algorithm, use the face recognitions, and it is method for efficiently representing the face using the principal component analysis. That is very important. This is a PCA we can use. That is one of the method. Okay, but we are not using a PCA, but we are using the different method, local based methods. Okay, the distribution based, the algorithm like PCA and feature discriminates can be used to define the subspace representing the facial patterns. There is a trend classifier we have to use, which currently identify the instance of the target patterns class from the background and image patterns. And neural network can be used. Many detection problems like object detections, face detections, emotion detections, and the face recognition, etc., have been faced successfully by the neural networks. So we have used sometime in the neural network also. The support vector machine are linear classifier that maximize the margin between the decisions, hyperplane, and the example in the training set. Okay, and sparse network windows also we use for this, and the naive based classifier we can use, and hidden Markov models we can use for the face detection. This is in the case of appearance based methods, because some training is required. Appearance based is the training is required. After training we have to create the model, we have to train the model. After training the model we can we have some predictions or that some recognition is possible. So this is what we have. This face and non-face example, as this is a positive example, get such variant as possible. Manually crop the normalize each. We have to normalize the each images into the standard size of these images. Okay, so that we have to convert into the standard size, so that we have to use resize function in the OpenCV. That is how to image we can resize it. Creating virtual examples. Okay, negative examples, any image that do not contain the faces, a large image subspace. Okay, right. So this is what the access to search. If you see that about this pre-processing is required. In this case, this is small image. There is we are not able to identify the space. If you increase the size of the image, you can find out this the image, and then pre-process it, classify it, and then after the pre-processing, we are able to find out all the faces here. This is across the locations. If you talk about the face recognition, it requires no physical interactions on the behalf of the user. It is accurate and allow for high enrollment and verification rates. It can use your existing hardware infrastructure, existing cameras and image. We will use the existing camera of our laptop camera. You can use your mobile camera also to extract all these things. Captured the device will work with no problems. The face recognition, there are two types. It is two tasks are there. To first identify the face and to verify the face. Given a face image had belongs to the person in the database, that tell the image. We will create a database of the image in our hands-on, and then after that we can in that images we can find out some other. We can check, we can recognize from the database whether this image is present or not present. Right. What is face recognitions? This we have to capture, we have to extract, we have to comparisons, and then we have to check match or no match. We have to capture means we have to capture from the video camera, and we have to normalize it. After normalizations, we have to store it, and then that is the learning part is there. After the learning, on the basis of that images, we can create the model. We can create the model, classifier model, and then classifier model will recognize the faces. Implementation, how to implement is first is image acquisitions, image processing, distinguished characteristics, locations, template creation, and template matching will do something. Okay. Image acquisitions, facial scan technology can this acquire the faces from the almost any static camera or the video systems that generates the image and sufficient. Maybe the camera is your camera or CCTV camera also, we can capture the data from that. Highly quality enrollment is essential to this for the verification and identification enrollment image. Define the facial characteristics to be used in the feature authentication events. Okay, this is what I capture the my faces from my camera, and different faces, different views are there, and we will create the model on these faces. After that, this face will generate the model, and then on the basis of that, these are the 100 images are there. On the basis of this 100 image, we can create the model. We can increase the image also. No issue. This I have created this model. These are different faces. I think it's visible to all of you. These are the faces I have created, and on the basis of that, we will learn we will learn what we will create the model, and then we will uh, perform the recognitions. The image processing is required. First, image are cropped such that avoid the facial image remains, and the color image are normally converted to the black and white. We have to convert into the black and white image. Yesterday we discussed about that. Then okay, then we have to convert into grayscale. We know that how to convert the image into the grayscale image. I think you remember all this thing, so that during hands-on we will discuss about, we will check, we will again see how to convert into the grayscale image. First, and then first the presence of the face or the face scan must be detected. Once the face is detected, it must be localized and normalized process may be required to bring the dimensions of the live facial sample in the alignment with the one-to-one check the one-to-one templates. Okay, that is a different thing. Template matching is there. We already discussed about that. A series of images are acquired in the stored against the enrollment, so that the user attempting one-to-one verification within the facial scan system, and 10 to 20 matches attempts take place in a 1 to 2 second. Facial scan is not as effective as a finger scan or iris scan. Is identifying a single individual from the large data set. A number of potential matches are generally returned after the large scale facial recognition. Okay, so this is how the facial recognition system works. The facial recognition system software is based on the ability to first recognize the face, which is the technologically fit itself. If you look at the mirror, you can see that your face has certain distinguishable landmarks are there in the depth. These are the peak of the face, and then some valley is there, and some this type of how this what the depth of this our eyes are there, how the eyes are depth from your peaks and all these things. So these are the things that there are about 80 nodal points in the human faces. Okay, right? How the facial recognition system works: distance between the eyes, width of nose, depth of the eye socket, cheekbones, jaw lines, and chin. On the basis of that, we can, these are the points, these are the basic points where we can recognize our face. Detection, this basically software means we are going to implement this this hands-on session. This, in this case, we will do what this, we will do the detection, we will do the alignment, we can do the normalization, we can representation, matching, and all these things we will do in our hands-on session. Okay, so strength is, it is the ability to leverage the existing image acquiring equipment. It can search against the static image such as driver license photograph. Also we can scan, we can identify that it is only biometrics able to operate without user interactions. Okay, weaknesses: change in the acquisition environment reduce the matching accuracy, right? Change in the physiological characteristic reduce the matching. We already discussed about that. It has the potential for the privacy abuse due to the non-cooperative enrollment, and right, because somebody is don't want to cooperate to take the picture and all this thing, that will be the privacy abuse. Okay, so identification capabilities are there, right? So the difference between face detection is the two class classification: face versus non-face. In the recognition multi-class, one person versus all others. We'll discuss about that. This application of this face recognition is access control, face database, face ID, HCI, and the law enforcement is there. This application of face recognition is multimedia management, security, smart cards, surveillances, and others. You can see that how the person will move from here. The cameras are there in the server. Server will identify, the guard workstation will identify, the security administrator workstation can do all these things. Database server is there, and then the person, when a person will move from this place, automatically this system will generate and this open this door. Okay, so this is what reading the face, body, all these things we can match here. Even then how this person will having a walk, they can capture this. How they are having the movement of their hand and all these things. Body's presentation is also can capture here, and all these things can be computed, and then automatically this gate will be open. And this, how you require a lot of big servers and a lot of internet bandwidth is required. In the local system, we require the fast speed. There's a fiber we required so that we can do all these things. The feature is feature from the global experience, principal component analysis we can use, the independent component analysis we can use, and then but we are using the local based, we will use the local based analysis for that. This any either we can use this local binary histogram face recognition we are using, not the PCA we'll use the local histogram for that. This is the for the PCA, but we will not go for the PCA and then all these things. So detection accuracy, if key issues, current phase false detection, missed detections are there, so that how we will implement it, we have to discuss about that, how we can implement it. This is what I have converted into 3 parts. The implementation part of this hands-on. This first part is ready data set. Collect the sample images through which we can train the model. Then I will collect the sample. I will collect the sample of my faces, and then again I already created the images, but we will create the image again, and we will create the database. And part 2, create the model, train the model. We will create the model. After that model, we can predict the data. Okay, this we will use in 3 parts. This note, I use the Anaconda for the Python. We already discussed in the last session. Jupyter Notebook we will use for the Pythons, or we can. I'm also using the Kaggle data set, Kaggle data and the Kaggle environment to run this. And then Colab is the Google environment for this data science people who are using normally. This is Kaggle and the Colab we can use. But today I am using the Jupyter Notebook for the today's session. I'm not using this third part because we are not having the time. Then we will use the Jupyter Notebook and the Python programming editor as an this, and then we can use the Anaconda for this. Okay, so this is what okay, this is what already computer vision we'll discuss about that. We already discussed. Okay, this computer vision we already discussed a lot of things yesterday. You know, that is very good thing is there. Now image versus matrix. Now because we store the image in the form of matrix, now this is the image where we can x and y coordinate begin with the 0. This is a left corner. When you see the image, we are already, this left corner is 0 0. But when you convert it, when you are using the OpenCV and all these things, we can start the 0 from the rightmost upper rightmost corner, upper left corner. But in the image we can see that left corner we can normally use in the theoretical part. This is 0 0 here. So that is what we will use. We have to check. Okay, we already discussed in the computer vision session also, right? And this, how many see the image, this is red, green and blue. These are the 3 channels are there. With the help of these 3, we can easily identify, we can extract the red channel, we can extract the green channel. We have seen in the computer vision session. And then on the all these 3 will combine and will create a one good image, right? The NumPy will use highly optimized library for the numerical based 2D array and 3D array. We can use the pixels, and OpenCV structures are converted in normal array. You can use the more convenient indexing system rather than using the loops. The indexing system is very good in the Python. With the help of NumPy, we can use it. Okay, these are what the implement. We can detect the face like this also, and then we can identify the other faces in this group. How many faces are there? How many faces are having a smile? How many faces are not smiling? We can identify this. How many faces are having the mask? How many faces are not having the mask? We can detect it. Okay, so we have to train the mask image also instead of this plain image, so that we can find out in the COVID days how many faces are having the mask and all these things, right? And how many faces are new, how many faces are unknown faces are there, we can identify. So that we have to create number of images of our same mindset people and same group of the people. We can train the data on all the images, and then we can find out the which image is not belongs to our group, so that we can clearly distinguish between your group and the other groups. Okay, this is what we can do here. This is what around the theory part of that. Now we'll go for the implement part. If you're having any questions, you can ask in the 2 minutes. Okay. Then after then 11:30 we'll start this the phase our hands-on. Asif,
Participants, you may write your queries in chat.
if you have any query, otherwise we'll go
Yes.
for hands-on directly. Okay.
Yes, of course.
Okay. Can I see my chat box? No, chat box is not open for me. Okay.
Sir, one question in chat.
Okay.
Please give some input if I want to find emotions from faces.
Emotion from faces, right?
Yes.
Then we have to detect that emotion, that different face. Normal face is that you look like the normal face. When you're happy, then the face will be changed, and when you are sad, then the face is changed. You know, that's the emotion. Emotionally, if you are so emotionally, then the face will be different like this. Okay. So the face detection is we have to classify it. We have to classify in the different categories. We have to classify this which type of face is there. Okay, so emotion face is also there is a one. We have to store the database of the emotional faces also. If you store the emotional faces data, then we can easily identify. Okay, you have to capture first, plus we have to train the data. We have to train the data on that. Okay, right? You will clearly understand when I will show you the hands-on. Okay, any other question?
Yes, sir. How we can that implement in Python?
Yes, I'll show you in the next hands-on. I'll show you the hands-on. Okay. The next part is our hands-on. We will implement it. Okay. I will show
Okay.
you. Any other question?
Yes, sir. What sort of server we will require to implement the campus security using surveillance system?
What?
What sort of server we will require to implement the
Now,
campus security using surveillance system?
this is a hardware part. There's a lot of and nowadays there is no limitation of the hardware. The hardware is available. You know, hardware is available, right? So hardware is available. A lot of servers are available. These servers, there are different types of server. Lot of servers are there. High end server basically required for the process all these things. So there is no discussion about that. What type of servers are available? High end servers. Even you can use your machine also. Normal machine nowadays available is good processing systems. If you are having a small surveillance systems, then you can use your memory up to the 8 GB, 10 GB RAM of is sufficient for that. Okay. Any other?
No, sir. No further question.
Okay, then should we go for the implementation, the hands-on part of this, please? If you are having your this we'll use the Anaconda, and this yesterday we discussed about that this Jupyter notebook. Then I use that. Okay, I'll just shift to this in the top. Okay, right. There is a very important library. Is the OpenCV library? Is the CV2. I have used that import this library. Okay, this is what, and you have to do that. This pip install OpenCV contrib Python. Please note down this. This very important library is used for the face recognition and face detection in the OpenCV. This we have installed pip install OpenCV. We have installed, but apart from that, we have to install OpenCV contrib Python. That is very important. Okay, so this is what I have included this OpenCV. Now we have discussed about that. We require the classifier to classify the image. Okay, then I use this classifier. This is a cascade classifier, and this classifier is available in when you install this OpenCV contrib Python and OpenCV. You can see this classifier is available in the Anaconda directory. This Anaconda lab side packages CV2 data. You can see in the data lot of classifiers are there. If I access this, different type of classifiers are there. I'll check this C colon, this Anaconda 3 library. This library is there is this, you can see that this is the library lib. Okay, this Anaconda 3, there is a lib, sorry, not in the library, that is the lib, and this lib we are having this site packages in CV2 data. This is site packages. Anaconda 3, and then okay, site packages. I think this is the site package, and in the site packages there is a one and data is there. Okay, right? We can see there is a CV2 and then data. Okay, then we can see this CV2, right? And this is CV2, and this CV2 we have the data. This data, these are the classifier. These are the different file of the classifier. XML files are there. These are the classifier. This classifier is this is a Har cascade full body classifier to train the data in the full body, and this is the this is a frontal face. We are using this frontal face, Har cascade, this frontal face. You can see this okay, easily. This is a frontal face classifier. I am using this frontal face classifier. This is what we can see that. To lower body classifier is that. Upper body classifier is that. For the pre-offline faces, that different type of classifiers are available. Here is the Anaconda library, or you can take it from the Kaggle or something else. This classifier, Colab and Kaggle is already include all this classifier. You can directly access from this particular path, or you can transfer this classifier to your package in your current directory. And this is XML file. Okay, this is the XML file. You can see this. I have used the Har cascade _ frontal face classifier. Okay, this is what I have done here. Then I have take the class. I create one classifier with the variable. This is a face classifier. Okay, this face classifier, and I have used the library of the cascade classifier. Okay, and after that we have to detect the face. For extracting the face, I have created one function. This function is the face extractor function. Okay, I create the face. Last time we discussed about that, how to create the function. These are face extractor functions. We can pass the image captured by the video camera to pass the image and detect the face. Detect the face means we have to detect this part. We have to crop this image. We have to detect this part of the face, so that first we have to convert. I already told you, we have to convert this image into the grayscale image. Okay, for grayscale image, we have used this function CV2 color image BGR to gray. Okay, we already discussed in the computer vision class. Okay, in session. And I use this face classifier. Face classifier is the face classifier, and there is one object is detect the multi-scale. We are using the detect the multi-scale function. This multi-scale function will classify this image, and this image is having gray image, and this 1.3 is scaling. Is I have checked it. The 1.3 is a good scaling, so that we can identify the face. If you'll increase it, so that we can find out the other object also nearby. So that for identification of the face, this 1.3 scaling is a good, and the 5 neighbors, we can identify the 5 neighbors also. This multi-scale classifiers. So after detecting this, if face is there, we have to check. After this, we'll store the face into the faces. If face is not there, then return the none. If face is there, then we have to extract the face. We have to extract only the face, means XY. We are extracting the face. What it will return? It will return what? This faces will return what? For X, Y, and W and H. W and H is width and height. X and Y is the beginning point of the top of this. From that we can extract the face. Then X and Y, this is what this four values we can return from the face for x and y in the faces. This is a loop we can use in the Python, and we can crop the face. We are having the image, this image, and this image is having the image file is there, and then image, this image will pass from this parameter. Okay, we'll pass the image. From that image we can extract, we have cropped this image. Already we have learned about that, how to crop the image. This is what the from y to y plus h to x plus h, this location from we can extract the image, and we can return this crop image, right? So that we have to capture the video, and from capturing the video we will extract this too, so that we can store for the learning purpose. We can store only the face from the image. Okay, for that we have to create this function, right? Now if you want to go after that, we have to implement, after detecting the face, after extracting the face, right? Then we will see how to, okay, just wait. Right, this is what, how to extract the face. This I have used this, you are familiar with this, cap is equals to cv2 dot video capture. Okay, it will use what, the your camera. Okay, right, this camera cv2 video capture, you can access the camera and transfer the picture into the cap variable. I use the count I use here because how many pictures you want to capture, so that I have put it in the 100 if 100 values are there, so that, or 100 or less than 100. We know only this line is this. We have to read the captures, and we have to read the video from this, and frame by frame, this one frame will transfer to the frame, and the success, and this, it will return the success. RET variable will return the success, true or false. Okay, so this frame I will transfer, this frame I will transfer to frame, this frame to face extractor function. This we already discussed, this face extractor function. This face extractor function, we will pass the frame as an image there, will transfer. If it is not none, means this frame is there, so that we have to put the count 1, means we want to count 100 images are there. So first of all, this frame, we have to convert this frame into a proper size. The size is, we have to convert resize into this 2020. Now this is a 200. This face extractor will return the cropped image and then convert into the 200 cross 200 size, because we have to check, we have to compare with this, and convert into the grayscale image. Okay, this face convert into the color, into the face to convert into the grayscale, BGR to grayscale. Okay, with the help of CV2 color functions. Now, you know, we have to store this, we have to store all these images in the particular folders. Then I have stored this folder in this file path name, this C colon my Python program faces and users file name. How to give the file name? This is user, and count is what? str count, that is user 1, user 2, user 3. Okay, .jpg we have stored in the jpg file. Okay, when you write, we will store this image, we will store in the form of this user 1, user 2, user 3, user 4. Okay, this is the file name path we have created here, and we can put it, how to put the some text on the image. Can see this by in the last session we'll discuss about that. cv2.put text, put text over the face. What the string count, we'll check count how many images, this 1 2 3 4, so that it can be used for the labeling of your images. Okay, so that 1 2 3 4 we can put count, and which location, 50 location, and by which font, and what is the the size of this font, and then color and the thickness. This is what we can use, and then after that IMShow, with the help of IMShow we can show the image on the screen, and then after that there is a IMWrite. You can see this is IMWrite. This IMWrite will write the image to the particular path. This path is file name path, is a variable. File name path is a create the variable. So in this location we can store the image, that is a face 1. Okay, right? Otherwise, if if face is not, face extractor will not able to recognize the face. This if face extractor, this is a if condition. This is a face extractor is a function. It will check whether the face is extracted or not, because we are using frontal face. We are classifier, we are using frontal face. Though if front face is not there, it will not recognize. So if it will not recognize, then it will give what? The face is not found. Okay. So that we have to maintain that frontal face is there, because we are using classifier. You can use the different classifier. Okay. Right. So this frontal face we are using here. And then last, if you are using, if CV2 wait key 1 is equal to 13, means when you are pressing the enter key, or the count is equal to 100, means I'm going to capture the 100 images. If any one of them is true, then it will break. Okay. And after that is very important. We will discuss about that. What? Cap dot release. We have to do that and destroy. This cap is what? Video capturing. We have initiated the cap is a variable to capture the video. Okay, from my video camera. Okay, so I'll going to start this now. For that we have to off my camera, because we are using, yesterday we discussed about that we have to off the camera. Okay, then stop video. Okay, right. So that how I'm going to run this. It is clear, I think so, all of you. Now I'm going to run this. First I have to run this function. Okay, I not run this function. This function is extract images. Okay, I have to run this function. Okay, this successfully run. Okay, no issue. That is successfully run. Okay, now I am going to detect, I am going to be storing the image. Okay, I'm going to start this. Something is wrong. Place classifier is not defined. Okay, we have to run, you know, the error is place, we have to run this place classifier, we have not run it. Okay, place classifier, and then again these face detections, right. Okay, now you can run it. You can see the images. Okay, you can see that image. 15 image is there, but face not found. Right. Right. You can see the faces. These are the counting is there. How many pictures we are going to create. Sometimes you can see that sometimes this face is not found. Okay. You can see that I am moving my face from here to there. Okay, there are 70 images captured by this particular program. Okay, 72, 73, 75, 76 images captured. Okay, more 20 images required, because we have given the loop for the 100 images. Okay, this 93, 96, 97, 100 images. Okay, these images are created. We can see that images are stored in this particular location of this. We already discussed about that. I'm in one session, huh? Okay, is DKM, not DKM. This is what? My Python program. The faces are stored are here. We can see that the faces are stored here. There is one image, two image, some images are there. Okay, Okay, you can see there's some images are there. We will train on the base of this image. Okay, right, so that you can see this. Again we can run this, and then what happened. Okay, now these are the images we have stored here. Okay, we can see some images. The wrong image can be stored. Why this is the right images is stored there. Okay, I have to check. I have to train all this. I have to remove this image. Sometime this wrong image earlier. I think so. These are the images. Okay, we have to train on that. Okay, we have to check some images are there. We can remove these images because these are faulty images. Because of this, I think camera position and lightening, I am sitting in a different place. So maybe possible this is the right. Okay. Lightening position are the different. Okay, now these are the images I have now. Now I'm going to this cell output. I have to clear the cell output. Okay, right. After this, creating the database and all these things, I had to identify these are the we have to create the model. This we have to generate the data set. We have to generate the data set. Now we have to create the model, and that model is what we have to predict the faces and all these things. We have sufficient time. Then because this is actually this I am going to use this for the Raspberry Pi 3 because I am going to implement in my CCTV camera all these things, so that I have limited library I have used here. This CV2 for the OpenCV and NumPy is a MP, and from the OS I am using only the list directory because I want to find out the directory from the locations. Okay, and then path, if file is there, and join. I am not importing entire OS here because OS is a big library. So this library I have used here. Okay, for using this. So the data path, I have to get the pictures from this particular path. This path is there. You can see the data path is C colon. My Python program faces from where we have to capture the data. Okay. And for this loop, this Python is very smart. This is a loop. In a one loop, we can do all these things. This is we are going to store into the F. This is a path. This, and from F to transfer to the only files. Okay, so for F in list dir data path, from data path we can check the list dir. List dir will get the list of these files are there. Okay, if files is there, they join with the path. Okay, this path is there. Okay, so this file is what user1, user2, user3. You can see this file name is user1, user2, user3. You know, user 68, user 69, something. We have to remove something here more. These are the wrong data. But not necessary to remove it, but it will work properly, no issue. Okay, these are the data set. we can, okay. Okay, these are the user file we can access from there. This data we can access, so that from my file, this is what if is file then join with the data path file, so that complete path will get in the only files. Okay, so print the only file. You can see if you run it, you can see that this number of files are there. Okay, right, number of files you can see that. And after that you have to train the data using this data set. Okay, so I'll clear the cell results. Okay, okay, this for the training the data, we required the data as well as the label, so that I have defined these two list variable. Okay, this list variable we define train data and the label data with the blank with this. Okay, and we will create the model for that. For one, this is the loop is required to fetch the file, the image path. This is what the file enumerated only files. We have the only files variable created by here. This is a list file. Okay, okay, created by here. This only file 1, only file 2, only file 3. We can read the image from the each files, so that we can read the image from the image path and convert into the grayscale first. Convert to the grayscale may be possible sometime. Already it's a grayscale image, so there is no need to convert, but we have to put in the practice. When you read the image, we have to convert to the grayscale. And each image we can transfer into the training data dot append, because this is a list, we can append it, and in the form of array, because you know image is in array, and model will accept the data in the form of array only, not the text image. Okay, so that with the help of numpy we can create we can convert this image into the unit 8 integer type image of the integer type, and convert to the array and stored into the training data, append one by one. And we can also append the labels, that is numbering on that. This is append I is the 1 2 3 4, so that picture name is there. Okay, and we can train the data labels. We are not having the time, I'm having the legs. Okay, label, we can convert the label also into the array form. Okay, this is the array is we converted, and then after that we can create the model. This model is what we are using. This I already discussed about that. We are having the model is local binary face histogram model, that is LB. We are not using PCA, we are using LBPH face recognizer, and this face recognizer will use the classifier is the frontal face classifier and create the model. Okay, this after creating the model, we have to train that model. This for training the model, this model dot train with, we require two variables. There is one is training data, and there is another is a label. So we can use these two things. Okay, and after that completion, we will print something. This model training is complete. So we have to train the model with the help of this, and okay, we will do it. We will train the model. Okay, our model training is complete. It's trained the model. Now this the main task is how to recognize. Again, we require the face classifier. Then we will use the face classifier here. Then we'll use the face classifier. Okay, after that face classifier we have defined there. Now we have to recognize the face. From when you capture the video, we have to recognize the face. For that first face detector, yes sir, I will be just finished by 15 minutes and then come to your place. Okay, hello. Right, this is a face detector. Face detector is this image. This detect the image, size is this, and this grayscale we can convert into the grayscale. And face classifier, we can use the multi-face classifier, just we use in there. Okay, this is a face classifier is there. Okay, and if faces are there, then return. If faces is not there, then return the blank image. If faces are there, then we have to crop that all these things. We already seen that how to crop the image and all these things. And that return the ROI, region of interest. This region of interest you have to return means this face detected, this portion we have to return. That ROI is nothing but this is the image, you can face image what we are getting from the trained faces, and resize is into the ROI into the 200 cross 200, because we store the faces in the 200 cross 200 images also. Okay, so after that we can use this main program. This is what capture, video capture. We'll capture the image from the video, and then we could read the images frame by frame. Okay, face detector will detect the face and analyze that whether this face is there or not, and after that we can convert into the grayscale, and result we can store the result of the model predictor. This model predict face we can store in the result. Okay, and this we have to check the confidence. Then confidence, for you to take the percentage of that. Okay, for that percentage we can check the confidence, how much confidence to have a picture is having result. Is the confidence means accuracy is there. So this accuracy we can print on the image screen. Okay, if there is and just wait. Yes, Nilanjan sir, you're just within 10 minutes I will finish it and then come to your point. Okay. Okay, because we have the time 12 o'clock, we have to start the another. Okay, this display screen. Okay, if confidence is more than 75%, then we can say this face is detected. Otherwise we can say this face is not detected. Okay, so this is what we have to use this. Okay, now I'll run it. You can see this is sometime face not found. This is unlocked. This is the face found. Okay, this is face found. If you turn it like this, face is not found. You know, this is what face found. Okay, this is the unlock. If you have the another face, if I am not having any face here, if you put any object, this is what face not found. Okay, face not found means logged. Okay, otherwise if this face is found, if this face is found, because this depend upon the image. I have created the image like this type of faces, so that is an unlocked. Okay, and 80% confidence are there in this frontal face image. You can see if this is, there is no confidence. Okay, this face is not found. Okay, this when you turn like this. Okay, this is unlocked and all these things. So you can create for your CCTV camera also and identify that particular face is logged and unlocked. Okay, the other, if the known persons are there, the automatically door will be unlocked, and right, so that you can create the model for that. Right, if you are having any doubt, you can ask the questions, because I have to attend another talk. Due to that, I was married in my house in the last week, so I shifted most of the talk to this week. Okay, please.
Sir, one question in chat. What is maximum limit we can set for count variable?
Any limit you can set. Any limit you can set. If the database is having number of more images are there, then accuracy is more. Okay, and not only you can store only one image, you can store multiple images, so that if multiple persons are come simultaneously, then you can this identify the faces and all these things. Okay, because more than one person can come simultaneously in the door, so that you can capture the all images, and if any one of them is from your group, then you can unlock it. Okay, right? Number of images.
Another question.
Yes.
Another question. We have used HAR classifier. Which classifier is best?
This basically I have used this local binary face histogram classifier for this, because I am using Raspberry Pi 3 to store. This is a lightweight. Okay, this is a lightweight protocols. Otherwise you can use PCA also. PCA is classifier is also good for that.
Participants, any more questions?
Gaurav, we can take question. We can collect question and we will share the question with the sir.
Right.
And,
okay. No issue.
Because sir has some other engagement.
Okay.
Right. Thank
okay.
You.
Only 5
Thank you very much, sir.
Okay.
Yeah, please.
It was really great listening to you, sir. and the way you explained everything convinced me that there could not have been a better person to discuss this topic with us today. But okay. Now I would like to invite Professor Ajay Khatri, Assistant Professor IT Department, for summary and to propose a vote of thanks. Over to you, Ajay sir.
Good afternoon, everyone. Good afternoon, everyone. I am Ajay Khatri and I am here to present the vote of thanks for today's session. I would like to thank our most valued, honorable speaker, Dr. Durgesh Kumar Mishra, for enlightening us with their knowledge. Today's session was full of knowledge and interesting things. The point where Dr. Durgesh Kumar Mishra told us about, first we discussed callback functions for click event in OpenCV using Python. Then we learn what is face detection and face recognition. And then we find what are the challenges, approaches, and strength and weakness in face detection and recognition. Then we see what are the different applications of face recognition. And in last, we have seen the live implementation of face recognition using OpenCV in Python. All these are very informative, and I'm pretty sure the precious knowledge that Dr. Mishra gave us will definitely help us in our studies and future. Once again, I would like to thank Dr. Durgesh Kumar Mishra for taking time for their busy schedule and enlightening us with their knowledge. Thank you so much, sir. I would also like to thank all the participants present here for paying your attention and learning. Thank you. Over to you, Guru, sir.
Thank you.
Thank you, Ajay sir.
Okay.
Thank you.
Thank you very much, sir. Durgesh sir, thank you very much.
Thank you, Kamal. Thank you, Ajay, and thank you, Gaurav. All these things. Thanks to invite me again, and we'll meet in the next if possible. Then we will have a one good session for this the computer vision and face recognition for the entire 1 day session if required. Okay. Thank you. Thank you.
Yes, yes sir, of course.
Thank you. So sorry for that. I have another session. Huh? Okay.
No problem. Thank you.
Thank you, sir.
Sir, shall we proceed for session?
Yeah, Tyagi sir has joined. Ajay, please make co-host Tyagi sir. And go ahead, Gaurav, please.
Okay, thank you, sir. By now, we all must have listened the word TensorFlow a lot number of times. Why not talk about the same today? Our second session for the day is about multi-dimensional data analysis using TensorFlow. I would like to invite Professor Ketki Tiwari, Assistant Professor IT Department, to introduce you all with the real master of data scientist at Infotech, Dr. Vikas Tyagi. Over to you, Ketki ma'am. Ketki ma'am.
Thank you, Goro sir. Am I audible, sir?
Yes, ma'am. You are audible. Ma'am, please slide show your presentation. Yes. Okay.
Thank you so much, Goro sir. Very good afternoon to everyone. It is my honor to introduce our guest, Dr. Vikas Tyagi. He is a senior data scientist at Infotech Limited, Noida, UP. He is having 15 years of mixed working experience in industry, research, and academics. He has done research on state-of-the-art NLP AI technologies for Assistant and published 14 research papers in international conferences and journals. And he is also author of 2 books and 2 book chapters. He has done certification in various fields like deep learning using TensorFlow in 2019 by IBM and Python for Everybody by Coursera and Executive Data Science Capstone by Coursera. He has completed his BSc in Physics Chemistry from Sahu Jain PG College, Najiabad, and received his MCA from UP Technical University and completed PhD in CSE from Ahmedabad University. On behalf of whole Acropolis family, I welcome you, sir. Okay, thank you so much. Thank you, Guru sir.
Thank you, madam. For further proceeding, I would like to take privilege to invite Dr. Vikas Tyagi for the formal commencement of the technical session. Over to you, Vikas, sir.
Okay, thank you, Professor Ketki, for the introduction. I would like to make one correction there. I am from Ahmedabad. My company is Ahmedabad based. We are having offices in different countries, but I am from Ahmedabad basically. My company is in Ahmedabad. Okay. So am I audible?
Yes, sir, you are audible.
Okay. So let me share my screen for presentation. So the presentation is visible.
Yes, sir, your presentation is visible.
Okay. So today we will learn how to handle the multi-dimensional data and how to make use of TensorFlow library. There exist many different frameworks for handling multi-dimensional data too. And if data is multi-dimensional and there is huge data, and moreover, if we are using the deep learning algorithms for solving our problem, then we have to adopt some framework, right? So this is the first screen. So I will go for introduction. A short introduction which Professor Ketki has given is, I think, enough. So I will introduce corporate and products, then multidimensional data, TensorFlow, data analysis, and implementation for solving the time series forecasting problem. So our company is in Ahmedabad and we are working on artificial intelligence. We are working on computer vision, natural language processing, and different optimization product. In real time optimization, we are using data science algorithms, right? So this is the published notice regarding use of images. I have prepared this presentation by taking the images by usual Google search, and some of the images may be copyrighted, but these are used only for the educational purpose, not for the commercial purpose. And these are the resources which I have used in my presentation. So online courses, Git repositories, research articles, then this is one of the book which I will recommend, Deep Learning with Python in 2017 from Franco Escolet. This is really a good book, and finally I will share two books with this presentation which may be very nice resources. And this tensorflow.org tutorial. So if someone is asking me that how to learn TensorFlow, I will recommend the first resource as the tensorflow.org, because this is the Google's framework, and material is good enough there, right? Then some article from the T-Zone, and our blog and article. You can explore our blog and article at this particular link. Our website is having those blogs. So, introduction to multi-dimensional data. See, whenever we are talking about the dimensions, so a data dimension is a set of data attribute, or we know that if our data is having only one dimension, then all the values will be stored in one list or the one dimensional array. So the values will be stored in one list only. If we have multiple lists or multiple attributes, then data can be restored in form of a table. And if we are talking about the table is two-dimensional because there exists only two dimensions. One is row and the other one is column. Similarly, if we are dealing with the images, then these are having three dimension or more dimension. So number of dimension may increase, and a human cannot get the perception of more than three dimensions. So we can visualize the effect of three dimensions in images and videos. So you can see that there exists different attributes there. So of yes, the data is not the one dimension. It will be table and the two dimensional data. Next, TensorFlow. So I think one dimensional data and two dimensional data, this part is clear, because if the data is having only one dimension, it can be stored or processed using the one dimensional array. And if data is having more dimensions, so there may be many applications, or if I say that most of the applications are using multi-dimensional data, then for handling such data, we have one framework which is TensorFlow. So let us see what is that framework. So TensorFlow is Google's open source machine learning framework for data flow programming across a range of tasks, and nodes in the graph represent mathematical operations, while the graph edges represent the multi-dimensional data arrays for communication between them. So we can say that tensors are just multi-dimensional arrays and extension of two-dimensional table to data with a larger dimension. And there are many features which I will talk in the next slides, which makes it suitable for deep learning algorithms. So whenever I am saying tensor, so you can visualize this mathematically as the matrix of matrices, right? If I am having only the one-dimensional data, then data can be represented as one-dimensional array, right? If I'm representing a matrix, then matrix is two-dimensional, which is having n cross m dimensions, where n is the number of rows and m is the number of columns. So if we are having element of a matrix, if element of a matrix are itself a matrix, then we call that structure as tensor. So tensors are used in physics extensively for solving the problems where we have the matrix of matrices. So such relations can be represented by using the tensors, and this framework is designed by the Google to handle such kind of data and such kind of operations effectively. So TensorFlow is having a graph structure in which node represent the operations and edges represent the data flow or the tensor flow between the operations. Now, tensor represent the connecting edges in any flow diagram called the data flow graph. So tensors are defined as multi-dimensional array or list. So tensor are identified by following three parameters: rank, shape, and types. So unit of dimensionality described within tensor is called the rank. It identifies the number of dimension of the tensor. And a rank of a tensor can be described as the order of n dimension of a tensor defined. The number of rows and columns together define the shape of tensor. Then type describes the data type assigned to tensor's element. A user need to consider the following activity for building a tensor: build n-dimensional array and convert the n-dimensional array and perform different operations using the TensorFlow. So we can see the various dimensions of TensorFlow. So one-dimensional tensor, if we are having a list of numbers only, then this can be represented as a one-dimensional tensor. If we are having row or columns, usually whatever we are having is the data which is stored in database in form of tables. So these tables are having two dimensions, and these are the 2D tensor. Similarly, three-dimensional tensor, four-dimensional tensor. So a tensor whose elements are two-dimensional tensor are known as three-dimensional tensor. Four-dimensional tensor is having its element as the three-dimensional tensor, and so on. So you can visualize it like a nested structures. Now, TensorFlow applications. During the STTP, you may have gone through the different applications in image processing, voice recognition, video detection, or text-based application. So for solving the problem in these domains, whether it is in image recognition, voice recognition, video detection, or text-based means we have developed our own assistant which is making use of natural language processing, natural language understanding, named entity recognition, and on the top of this NLP engine, we are able to build a platform where a user can build his chatbot based on his requirement. And if you are interested to see Other awesome projects done by the open source community, these are listed here at this link. If I go at this link, so this is having list of very nice projects. So deep speech Mandarin by Baidu, then this rank brain by Google, and see, you can find these lists here, and products, different products can be built by using the TensorFlow. We have built 4 products using the TensorFlow, use of TensorFlow. So the you can make use of TensorFlow's application in any domain for solving a real world problem. So this is one of the link or resource for exploring the applications of TensorFlow in uh, different domains. Then then we will see that if not TensorFlow, then what else? So the common deep learning packages which can be used are Torch. So Torch is a scientific computing framework with underlying C implementation and Lua JIT and as a scripting language. So initial release of Torch was in 2002. Operating system on which Torch works are Linux, Android, Mac, and this one. So this is another framework, right? And reputed organizations such as Facebook AI Research, and IBM use Torch. So Torch can utilize GPU for faster computation, and this, based on my experience, I can say that in some application, Torch perform better than the TensorFlow. But TensorFlow is more popular than Torch. So we can make the selection of deep learning framework available with us based on our requirement. But as a thumb rule, and the availability or the uh, availability of online open source libraries, I will recommend the TensorFlow. So Theano is also another deep learning package in Python that is used for computationally intensive research oriented activities. Similarly, Cafe is also one of the framework by Berkeley AI Research. Then you can see CUDNN. So it stands for CUDA Deep Neural Network Library. It provides a library of primitives for GPU implementation of deep neural network. So we need CUDNN if we are using TensorFlow on GPU devices. On my machine, if I am having multiple GPUs, then I have to install the CUDNN libraries. And on the top of it, I have to install the TensorFlow GPU version. So TensorFlow has 2 versions. One is CPU and the other one is GPU version. TensorFlow supports the distributed computing, and therefore the computations which are having which require a lot of which are heavy in computation can make use of TensorFlow. Then MXNet is another library which can scale to multiple GPUs and supported by major cloud providers such as AWS and Azure. So popular machine learning libraries, GraphLab has good deep learning implementation using MXNet. So MXNet, TensorFlow, these frameworks are also available in the AWS SageMaker. You can make use of these frameworks in SageMaker and develop your application using Amazon Web Services. Nowadays, Amazon Web Services are also very popular, and they have their inbuilt algorithms too, which you can make use for solving your problem. And Deep Learning 4J is also open source distributed deep learning framework for Java virtual machines. Then salient features of deep learning frameworks, all the frameworks which I have defined, which I have discussed in the previous slide. So Python is the high-level language of choice for TensorFlow and Theano, whereas Lua is the high-level programming language of choice for Torch. Although I have not used Lua, I am using Python and R for data wrangling and data visualization and for statistical analysis. MXNet also has Python APIs. So these frameworks are exposed as the APIs, and those APIs can be used in a program for solving a problem. Then TensorFlow and Theano are very similar in nature, but TensorFlow has better support because whenever we are solving a problem and we are making use of any of the library, at many points we stuck, and whenever we are finding the supports, so sometimes it fails, and backward compatibility is also required while solving a problem. So existence of support in case of TensorFlow is sufficient enough for solving any innovative problem. So TensorFlow, Theano, IMSNet, and Cafe all use automatic differentiator, while Torch use autograd automatic differentiator are different from symbolic differentiation and numerical differentiation. Automatic differentiation are very efficient when used in neural network because of the back propagation method of learning that utilizes the chain rule of differentiation. Right. So for production implementation on cloud, TensorFlow is on its way to becoming the go-go platform or very popular enough. Recent version of TensorFlow 2.0 is also having some more features, and the limitations of TensorFlow, which were covered by Torch, are also covered in TensorFlow 2.0. So if you are using TensorFlow 2.0, then you don't need, you will not feel the requirement of other deep learning framework. TensorFlow will be able to fulfill all the requirements for solving real world problems. Now we will see a real world problem related with the time series forecasting. So we will see that what the time series is. The time series is a series of data points ordered in time. Means uh, the values are dependent on time and are having some patterns with respect to time. So in time series, the order of observations provides a source of additional information that should be analyzed and used in the prediction process. Time series are typically assumed to be generated at regularly spaced interval of time and so are called regular time series. So time series may be regular time series or irregular time series. If the time interval is irregular, then it is known as the irregular time series. So irregular time series data is coming from the source at regular intervals. Suppose we are deploying some IoT device and we are setting that at every 5 second we will get the data. Then that interval is fixed by the developers. And in irregular time series, whenever something happens, the data is sent to the system and for analysis. So in irregular time series, the data follows a temporal sequence, but the measurements might not occur at a regular time interval. Similarly, the classification of time series may be the univariate time series or a multivariate time series. So your target may depend only on one variable, or it may depend on multiple variables. So based on that feature in your problem, you can define that the time series is either univariate or multivariate. Now, time series are used in various fields such as mathematical finance, manufacturing, event data, IoT data, and generally in the domain of applied science and engineering, which involve temporal measurement. And we have also submitted one proposal and got the funding from Ministry of Electronics and IT for developing a water supply monitoring and preventive maintenance solution. So whenever we are implementing or deploying some IoT sensors and we are collecting the data, IoT sensors will send you the data, and the next job is the efficient analysis of that data and finding out the data insights. Those data insights help taking the valuable decisions. So nowadays, real-time data is having spatio-temporal properties, and whenever time is involved there, so we can make use of that time feature or that ordering time feature as one of the important feature. It will be used only after the careful analysis or data exploration or data handling. Now, types of time series are the deterministic time series, non-deterministic time series, stationary time series, or non-stationary time series. The non-stationary patterns are the trend component, cyclical component, seasonal component, and random component. So, next in my presentation, I will show you one notebook in which you can see that how to handle the time series. So I will go for this one. Yeah, so while solving any problem using the machine learning or deep learning, first thing is we need to get the data and we need to analyze the data using the different functions which we have seen in the in some of the sessions. So although in development or in production Jupyter notebooks are not used, but these are good enough for data visualization or data wrangling. I have taken this notebook from the TensorFlow authors, and this one is again copyrighted and having some link here. I have provided that link in my presentation. So this may be the link of this notebook or TensorFlow forecasting. I have taken this reference. So uh, let us try to run it. So looking at this notebook and this tutorial, we can see that it is implementing CNN, RNN algorithms, and let us try to run this else. So the data set which is used, let us see at the data set, because data is very important. Looking at the data, we can see this tutorial uses a weather time series data. Whenever we are talking about the weather, so weather is a time series data. It depends on time and changing with the time and having some patterns. So weather changes in fact during a day, and so we will download this data recorded by the Max Planck Institute. So run this file. So this data contain 14 different features such as air temperature, atmospheric pressure, and humidity. These were collected every 10 minutes, beginning in 2003. For efficiency, you can use only the data collected within this one. So we can take the data for the time in which we are interested in. Then after taking the data, this data frame is generated. So this data frame, pandas data frame is reading the data from CSV path. CSV path is this one, and this CSV.cp is stored there, extracted there. So it is extracted at now let's see the DF head. So this DF head is having P, T, Tpot, TW, RH, Max, these features. So there are many features in the data, and these are the plots for temperature, pressure, and RHO. Right? We can see some pattern here. So this is the temperature degree C, which is giving us some observations that the temperature is increasing and then decreasing, and the same pattern is occurring during some time interval, and the time interval seems to be constant, right, during the years in 2010. So what we can observe from this graph, this is the temperature. Look at the blue graph. So in 2010, 2011, 2012, 13, 14, 15. So the data is taken from the 2009 to 2016. And during this 2010, the data is having the temperature is increasing and decreasing. So there exists some pattern here, right? And these patterns may be very useful for our classification problem, or maybe for the regression problem. Now let us inspect and clean. So describe and transport. So this is the statistics of data. Main statistics are the count, mean, standard deviation, min, max, right? So these are the statistics which we can observe here, or we can visualize these things. Then look at the wind velocity. And then we come at the feature engineering. So first thing, whenever we are getting the data from any source, first we need to make a data frame, and from the data frame we need to look at the statistics. Statistics are very important for giving you a basic understanding about the feature engineering, because you can see how features are related with each other. So you can also look at the variance and so this is a plot for when uh, yes. This feature engineering gives you a proper understanding of the data, or you can say that both the things are parallelly. Your understanding is being used for generating the good features. So we are looking at the wind. The last column of data is WD, gives the wind direction, right? Wind direction and units are in degree. Angles do not make good model input. 360 degree and 0 degree should be close to each other. Wrap around smoothly. Direction shouldn't matter if the wind is not blowing. So the distribution of wind data is plotted there. This is the his 2D plot, WT and WB, wind direction and wind velocity. So both the things are plotted here, and we can see that on x-axis we are having wind direction, and on y-axis we are having wind velocity. Now, looking at this graph, this is the wind direction degree, and this is the wind velocity. So if wind velocity is 0, this angle does not matter. 360 or 0 both are same, and we can see that there is some normal kind of distribution there. Now let us make wind direction and wind velocity column to a wind vector. So wind vector, let us see how this wind vector is. We have drawn this column, and we have done that. We have converted to radians, the degree into radian, and we got pi by 180. So if we are converting the degree into radian, we can multiply by pi by 180 and calculate the wind x and y component. So we are taking the cos and sines for that. Now this is actually another way of looking at the wind vectors visualization. This is also another visualization of your data for giving you a proper understanding. Now look at the time feature. So time column is also very useful, but not in the string format, which we are having usually in the time format. So let us convert it into seconds. So whatever we are doing is just the feature engineering. So in the raw data, we are having data, and we have to convert it in processable form. Believe me, most of the time of data scientists goes into the data collection and data cleaning. I can roughly say that it is approximately 80% of the time goes into data cleaning and data preparation. Rest of the thing, once you understand the data properly, then you can work with the model hyperparameter tuning and training the models, right? So data understanding and data wrangling is very important part of data science solution or machine learning solution. Now handling the time. So we map this date time with date time dot timestamp. So timestamp is giving you the timestamp corresponding to the string given in your data. This is time of day signal, and it's a matter. Let us see what that error is. Okay, this is internal output. Data type not understood. Digital run at this. Let me look at this reference. This is- So, anyways, I will go at this reference and will use this reference further. So, what we have done, we have taken this signal FFT, fast Fourier transform, for this key signal, and completed this feature engineering task, which is giving us the patterns in different features. So for time feature, uh, for time we have taken this FFT feature, and you can see the frequency log scale at frequency log scale at x-axis here. And then once these features are with us, so let me add this one. So we have taken this R per year per data set, F per year, and number of samplage is this one, the temperature, and FFT and F per data set. These are the features. So after feature engineering, we have to split the data for our development and testing. So this is the dev set, test set, and validation set. So 70-20-10, or maybe 70-15-15. So we will split the training, validation, and test set, and data is not being randomly shuffled. Usually we shuffle the data, but in case of time series, we don't need to shuffle the data, because if we are shuffling, then we are missing the ordering or the temporal property available in the data. So for retaining the temporal property, we don't need to randomly shuffle the splitted data. Then we need to normalize the data using some normalization techniques. So this is the train mean is train standard deviation, right? And this is train validation and test data frames. Now we can plot these standard deviations. Now data windowing. Data windowing is also very important in time series analysis. So the model makes a set of prediction based on a window of consecutive samples from data. And the features of data windows are the width, which is the number of time steps of the input, and label window, and the time offset between them, and which features are used as input, label, or both. So next shells we will see the DNN, CNN, RNN model, and we'll see that single output and multiple output prediction, single time step and multi-time step predictions. So depending on the task and type of model, you may want to generate a variety of data window, and these are the samples. So t equal to 0, t equal to 1, t equal to 2, and so on. These are the steps which you can set for your problem. So a model that make a prediction for 1 hour into the future gives 6 hours of history would need a window like this, right? So this is the input width. 0 to 5 is the width of length 6. This is the window which is used for the prediction for the next one. And in next section, window generators are there. Then index and offsets. So this module create the logic for input and label indices. It also take the train eval and test data frame as input, and this will convert into the TF data set of window data. So this is a function which is performing these indexes and offsets. So here windows are being generated by using this window generator function. Window generator function is defined as per the requirements by using the workout label column indices and raw data, storing the raw data in the column indices, window parameters. So these are important while dealing with the uh, time series data. Then consecutive input for a split window method to convert them a window of input and a window of label. So from the above example for W2, the split is performed like that. This is label of label width 1, and input width is 6, 0 to 5, and then t equal to 0 to t equal to 5 input, or 6 is predicted. Now the window plots are there for T. So model is like that. We are having inputs for some of the time step data, and then we are predicting the next one. And once the next is predicted, then we will slide the window and we'll take the data and we'll predict for the next one. So T0 is input, model is prepared. For t equal to 1, predictions are made, and for t equal to 1, we are having label. This will so baseline before coming at some conclusion or evaluating the models, we need to define the baseline. And for baseline, what we actually do, we have the actual values with us, which are not used in the dev set. And suppose we are having thousands of record, so we can say that we are taking only the 900 records for our model. And from 900, we are performing those splits, dev, test and validation splits. Then the remaining 100 records will be used for the baseline calculation or baseline model. So whatever model we will train, we will compare with the baseline, and then these Windows predictions will be compared with this one. So there are different models, linear model, and this is a neural network model with two layers, dense layers, and multi-step dense model. So looking at this course, you can see that we can implement the algorithms after feature engineering and Windows and other parameters definition. We can go for implementing different models by using different functions and define the our network structure here. So this is the convolution 1D and dense layer. So now we will go for the results. For RNN. So for all the model, these things are fixed. We are having inputs when training the model, making the prediction, comparing the prediction with the labels in the baseline, and then we are making some decision regarding the model or algorithm which we are using for prediction. Now for performance comparison, we can plot a bar plot for different algorithms. This is interesting. So mean absolute error for evaluating this for fitting this value or prediction. So baseline is this one, and linear is this one, dense is this one, multi-step dense is this one, convolution is this one, and LSTM is performing this one. We can say that this linear is performing better on validation test, validation set, and test set. For this particular example, that it may not be true for every problem. So looking at the problem, based depending on the data, you have to perform this algorithm selection, and after this algorithm selection, you need to build a training model file and then the prediction file. So while putting some algorithm or for forecasting in production, we need to perform these steps separately using maybe a Jupyter notebook or performing individually, right? So in after the performance comparison, we need to make some decisions. So there are many algorithms here which are compared. So after comparison, the decision can be made that which algorithm is performing better for this particular case, and if we are using this for solving our problem. So this is just changing the parameters, window size, and different things here, and tuning the parameters for finding the best solution. So this is another again the performance comparison, and here also we will see that this dense is performing better than LSTM and residual LSTM. So different changes in the network, right? Changes in the parameters are required while adopting any solution. See, you can play with the code available here. I'm going to explain all the codes here. But simply, the moral of the story is if someone is interested to learn the TensorFlow and is forecasting, so time series forecasting is in fact a domain in itself. And looking at the problem, you need to perform some algorithm. You need to perform the algorithm comparison and feature engineering, and then need to make the algorithm selection. And once the algorithm is finalized, then only you can make use of that algorithm for solving your problem, and then it can be put in the production. So the main thing is time series is important, and for some data like the algorithmic trading or script prediction, that can be modeled as time series, and weather forecasting is also time series. Agriculture crop yield prediction is also a time series. And in fact, in one of our products, which was the crash prediction, so we have made use of forecasting there using the weather data, and we were forecasting the uh, crashes which are going to be happen in upcoming 5 days. So this is one good reference point where someone can start learning the TensorFlow and using TensorFlow for solving the time series forecasting. In fact, when I was using this notebook, I got this error, and I said there. So at some point, it happens. Unfortunately, I could not resolve this error here. But yes, if we are executing the code line by line, it will be helpful, and we can also debug. We can also make use of some Jupyter tricks which may be helpful for debugging. I have not explored those tricks yet, but yes, there exists some debugging mechanism too, using which you can debug the code, or you can find out the error and solve it quickly. So I think this is just a bird's eye view on time series forecasting using the TensorFlow. So this is a good start point for modeling the time series. And I think I should stop here now. And let me take this presentation. Yes, this is all. Thank you so much. And you can explore the uses of TensorFlow in many of the applications which we are having on our website and blogs. So if you go onto the blog and articles or our report site, you will see that many products are making use of the deep learning algorithms for face recognition based attendance system. Yes, we are using this TensorFlow and MXNet models there. And in our assistant framework, we are making use of the RNN and LSTM model for natural language understanding. And in our Radiant product, we are using time series forecasting for energy forecast for upcoming days based on the weather parameter. So in our Radiant product, uh, from the solar panel, sensors are deployed there and sensors are sending us the data, which is the temporal data. And on the top of this temporal data, we are making the prediction for the energy production for upcoming days. And once we are having these things, and if that prediction is not matching, so again we are sliding that window. We are taking the 1 month past 1 month's data and predicting for 5 days. So again, all the problems or all kind of data cannot be directly used for this one. The data is not numerical. So first thing is you need to find out whether the data is having numeric properties or not, or whether it can be used for deep learning or not. So in our case, I am making use of the simple random forest algorithms for solving our problem. Okay, so that's all. Thank you so much.
Thank you, sir. This session surely opened the vistas of knowledge in this topic. Participants, if you have any doubt or question related to the topic, you may ask through chat or can unmute your mic and ask in person.
Voluntary होगा मेरा भी वो है कि voluntary कोई पैसा देता ही नहीं है.
Vikas sir?
Yes, hello.
Sir, one question in chat. How to handle categorical target in TS?
Yeah, see, categorical, you need to use the encoding, maybe one hot encoding, or you have to do some kind of coding there. First, you need to convert, you need to transform your categorical feature into numbers, because everything which is handled there is the numbers only.
Any more question, participants? Okay, sir. There is no more question. So we are done with our question answer round. Now I would like to invite Professor Ronak Jain, Assistant Professor IT Department, to summarize this session and propose a vote of thanks. Over to you, Ronak, sir. Ronak, sir.
Am I audible, Gaurav sir?
Yes, sir. You are audible now.
Okay. Thank you for providing me opportunity to present, to summarize the session and present vote of thanks. Um, uh, so first, I would summarize the session. Sir has started his session by introducing the multidimensional data and what is data dimension. He has introduced TensorFlow, which is Google's open source machine learning framework for data flow programming. And tensors are just a multidimensional array, an extension of 2D tables. TensorFlow includes various dimensions. He has also shared various applications of TensorFlow, which are image recognition, voice recognition, video detection, text-based applications. Some deep learning packages were also introduced by him, which are Torch, Theano, Cafe, CUDNN, etc. So then he has demonstrated uh, using Jupyter Notebook how TensorFlow works. He has taken a time series forecasting data set, uh, which is weather time series data set of Max Planck Institute. And then he has shown how to read data set into data frame, then how to plot various patterns. He has also explained feature engineering, which is important to understand the data before deriving a model. Data statistics is the way to understand the data, how to pre-process data, to prepare the data before modeling. Then after data pre-processing and data preparation, he has derived various types of models. CNN, DNN, RNN models were generated, and after generation of models, predictions were done with the help of models. Also explained how to evaluate the model by comparing with the baseline. So the entire session was very informative. uh, we have learned so many things from this session. So now I would thank Mr. Vikas sir from bottom of my heart and on behalf of the institute. Thank you very much, sir, for this informative session, and thank you everyone. Uh, Thank you every participant and organizers for this STTP. Thank you.
Thank you so much,
Thank you,
sir.
Ronak. Thank you, Vikas sir.
Welcome, sir.
Kamal sir, shall we take lunch break?
Okay, I should stop here. Thank you.
Yes, Gaurav.
Okay, thank you, ma'am. Dear participants, let us break for lunch. We assemble again at sharp 2:30 p.m. for next session. If you want to stay in meeting, you can, but please be sure that your mic is muted. Dear participants, feedback link is shared for session 2. Kavin sir?
Yes, Gaurav sir.
Sridhar has joined or not?
He has joined. Sridhar sir has joined.
Okay.
I'm online, sir.
Okay. Okay, sir. Thank you. Kamal sir, shall we proceed?
Yes, Guru, go ahead.
Okay. Thank you. Good afternoon, all of you. Deep neural net optimization and tuning. Does this sound
जितने भारी
familiar?
बचोगे ना उससे ज्यादा लोगों ने नाम लिख दिए हमने।
Yes. Kudos to your
तो
knowledge.
ऐसा भी नहीं हुआ था कि सॉरी।
Hello. Deep neural net optimization and tuning. Does this sound familiar to you all? Yes. Kudos to your knowledge. If not, then that's okay. Our third session is about the same. I would like to invite Professor Akshita Sharma, Assistant Professor IT Department, to introduce our prominent speaker, Dr. Sridhar Swaminathan, Assistant Professor, Bennett University, to edify us with his knowledge on this topic. Over to you, ma'am. Hello. Shita ma'am?
Yes, sir.
Okay.
Very good afternoon to everyone. It is a great honor for me to introduce and welcome our eminent speaker, Dr. Sridhar Swaminathan, for our third session of the day. Dr. Sridhar barely requires any introduction though. He is an assistant professor in Computer Science Engineering Department at Bennett University. He is also NVIDIA DLI Ambassador for Computer Vision, Natural Language Processing and multiple data types. Dr. Sridhar has more than 3 years of experience in academics and research, and his major research areas include computer vision, information retrieval, machine learning, video summarization, object detection and tracking, and sentiment mining. He has more than 5 research papers published in various international publications. Talking about his academic achievements, he has received his bachelor's degree in year 2010 from Bishop Heber College, Trichy, and his master's degree in 2012 from Bishop Heber College, Trichy. He got his doctorate degree in year 2015 from Bharti Hardassan University, Trichy. He has also worked as a research officer in Multimedia University, Malaysia, where his research projects have been funded by Telecom Malaysia. These are some of his key projects that have been funded. This is a real-time multilingual customer sentiment mining system that he has developed. It was first successful sentiment analysis and visualization tool for the Malay language for the telecommunication company Telecom Malaysia. And another project was SMS sentiment mining application, which was again developed or funded by Telecom Malaysia. It is an honor for us to have you here, Sridhar sir. Thank you and welcome. Over to you.
Thank you, madam. Thank you, madam. It's an honor to invite our honorable speaker, Dr. Sridhar, for formal commencement to this technical session. Over to you.
So thank you, Gaurav sir and Akshita madam for the nice introduction. I'm really very happy to be here again. So I hope I'm audible. I'm going to turn off my camera and start the presentation now. So
Yes, sir,
today's topic will be very interesting, and it will be like having some new components in the deep learning research. So that is actually deep learning model optimization and tuning. So, so there are like a few terminologies here, and I'll try to clarify before we dive deep into it. So first one is like deep learning model. So deep learning model, what we mean is actually neural networks and the different varieties of neural network. We have dense neural network and convolutional neural network, and we have like a recurrent neural network. All these are actually varieties of neural network, and collectively they called as deep learning model. Okay, and we are actually going to optimize and then tune it for better performance. Okay, so this optimization and tuning is actually for model optimization. Okay, not for training but for deployment. Okay, what do you mean by deployment? After training the model, we want to actually keep the model in some application. We want the model to meet the real-time requirements. We want the model to be faster. We want the model to be smaller. So we try to do those kind of model optimizations, and we want to like tune those models for meeting the real-time requirements. Okay, so this optimization doesn't mean hyperparameter optimization. This is not for training. This is actually after the training. After you train a neural network using a learning algorithm like gradient descent or momentum or adaptive grad, ADAM, RMS prop, all these are actually neural network model optimizers for weight learning. Okay, so we try to learn weights and biases through those optimizers. Okay, but this optimization is actually optimizing the trained model. How do we optimize the trained model? How you tune those model so that it actually goes for a better deployment. Okay, so you all be like very familiar with this diagram. I don't want to repeat it again, but what we want to do is like we want to go for step 6, which is actually the optimization. After you train, after you test, after you improve, you want to actually do some optimization in the model. So let's see all the requirements. What actually happens in the deep learning models. So there are like 2 major steps. One is actually training, other one is actually called the inference. So training is actually building the model. So for training, what you will have some data set, and you will have some model which is actually like having random weights and biases. Then what you have a deep learning framework to train this model, and then we have a training set. Then what will happen, the model will be like updating the weights and biases, and this will be actually happening in the on-premise or the cloud host. Means it may happen in a supercomputer or it can happen in a like cloud. Okay, there are many cloud servers like Amazon AWS, and then like Google cloud platform. Then we have like Azure platform. So many cloud services are there. Then we have like a Google Colab. Google Colab is also a really good platform for running the model in the online. So training will be happening. After that model is trained, we try to go to the like deployment stage, where this deployment will be happening on edge devices or on premises or cloud hosted. What we mean by like edge devices, these are actually mobile devices, or it can be like a small Arduino board, or it can be like a Raspberry Pi device, or it can be a smart watch. It can be anything. It can be a small device, edge device. Okay, so that step is actually called the inference. Inference means you take a trained model, then you deploy it in a cloud application. Sometime you have a mobile app and you click a picture, and the picture will be like uploaded to the cloud, and then the model which is running in the cloud will like process the image, and then it will like give the result. So example will be like a face app, Prisma. All these applications are actually running in the cloud only. So your device, mobile device, takes some pictures, and then the actual processing is actually happening in the cloud only. So because of that, you need to have an internet connection to run these applications. Without internet, you cannot run this application. So it can happen sometime within the device itself. Some apps work even without having interconnection. Sometime like filters in your Snapchat or filters in your Instagram, face filters, beautifying filters, bridal filters, like you want to have like dress filters. All these filters are sometimes working in the device itself, and those models are running from your mobile itself. It doesn't go to the cloud and then do the processing. So sometimes the AI model can run in the cloud, and sometimes the AI model can run in the device itself, or sometimes it can be running in the like personal computers as a desktop application. Okay, so what we do here, we take a trained model, and then we actually like take the trained model, we take the new data which is actually like totally new, which is never seen by the model, and then you pre-process the data, then you give it to the model, and then the model will actually give a label like cat. Or if it is a regression model, it can give like some real number. Sometimes you give a face image, and then the features of the face will be uh, helping you to predict the age of the people. Okay, so something like 32. So some cameras, they have this application for age prediction. So this is a regression problem. And when the problem is actually like handled in the mobile devices or in the inference stage, there will be no one to tell what is the percentage of accuracy. Okay, and this will be happening in real time. That is the thing, and this will be happening offline. Model training can happen in anywhere. It can happen in a supercomputer in your college, or it can happen in a maybe a personal computer in your home, or it can happen in your laptop, or you may be running a model in the Google Colab. It will be like done offline, and people don't really worry how much time it actually takes to train the model. Okay, nobody really worries like how much time the model is taking for training. Okay, of course we want the model to be training faster, but people don't really worry about that. But what people actually worry is when you give a single image or like a single audio sample, we want the model to be working in real time. Okay, so we want to meet this real time requirement, and especially here you are not going to use any supercomputer. Okay, and that is actually like one drawback. And sometime you may be using a edge device, mobile computers, like small devices like mobile phones, Raspberry Pi devices, and you want to run these models which were trained on supercomputers. We want to run these models in small devices. Okay, so that is actually the main challenge in deploying the model. So when the machine learning or deep learning engineer actually develop a model, he doesn't really care about how the people are going to deploy the model. Okay, so he just want the model with some good accuracy like 9800. Okay, but he doesn't really care about how this model is going to run in a edge device. Okay, so imagine that the model you are training is actually having a weight of 1 GB. So the weights of your model is actually having size of 1 GB. Do you think like people will download a mobile application from Google Play Store, from Google Play, just for like face filtering the face? Do you think like people will download the 1 GB model and then the APK file will be of size 1 GB? No, right? So again, you need to think maybe this model was trained in like 8 GB RAM, and then like there was like a lot of good processor, so i7 processor, and then maybe 32 GB of GPU, and you want to run the same model in a small device which is having limited memory. Maybe the main memory is actually just 2 GB. Maybe your phone memory is just 2 GB. Then the hard disk is like sorry, not hard disk, internal memory is like very limited. Maybe just 8 GB of internal memory, very small device. So in that case, you need to cater to these requirements. Maybe the model can be like gigantic, but it cannot be in the same size when you want to deploy the model. So the main challenge is how do we optimize these kind of bigger models for adapting to the smaller devices. So that is what the optimization that we try to do. Okay, so the devices can be like phones, or it can be drones. Yeah, this is a really good example. So we want to actually do some real-time processing in drones sometime. So for that, you will be like having a simple camera in the drone and then maybe a simple processor. And to run this drone, there'll be like batteries will here. And the model should not be taking too much of your battery also. That is one more constraint, that these are actually resource constrained devices. Resource constrained devices means the resources of the devices are like really less and then constrained. So what are those resources? One is actually the memory, storage, second is the speed, and third is the energy. So limited battery, limited memory, limited speed, how you are going to manage? Similarly, like robots also have like limited energy only, and the speed and memory can be managed. Sometimes you have like independent devices like glasses, smart glasses, self-driving car. Okay, so all these devices are actually battery constrained, and you want to do some processing in real time. Okay, forget about the battery, but how do you do the things in real time? Like whenever an image comes in the next 100 or like maybe 50 milliseconds, you need to see the output. So model should be like quickly responding to the input. And if the size of the image is really bigger, then giving an output of really bigger size, that is again a challenge. So how do we solve it? So let's see. Here is a like a model from neural network family called AlexNet, and this is really a big neural network. What do you mean by big or huge neural network? So the number of parameters in the AlexNet model, it was the first successful convolutional neural network proposed in 2012 and become a landmark paper in the history of deep learning. And the reason why we are all studying about deep learning and artificial intelligence is because of this particular paper proposed by a guy called Koveski. That professor has proposed a model like this. And this model is actually having 60 million parameters. Okay. What we mean by parameter? Parameters are nothing but your weights and your biases. So from where these parameters are actually coming? So if you just take the model parameters, so parameters are actually coming from two places. In your CNN, convolutional neural network, there are actually two layers, two type of layers. One is actually a convolution layer and the other one is actually dense layer. So dense is what we already know, dense neural network. Every node is like connected with every other node. And convolutional neural network, we have operation called convolution. So there also we have something called kernels, convolution kernels. And again, they also will be having some kind of weights and biases. So instead of matrix multiplication, they'll be doing something called convolution operation or filtering. Okay, so this is your first convolution layer, and the number of parameters are 35,000. After that, we have like some like normalization and then pooling. After that, second convolution layer, the size of your convolution is like 5 by 5, and then number of filters are 256. Here size of the kernel is like 11 by 11, number of filters are 96. So here the comparatively like larger parameters are there. So once you actually move to the third convolution, you have like 884 parameters. So now you can see that number of parameters are actually increasing one by one. So this is like the first C convolution layer, second convolution layer, third convolution layer, fourth convolution layer, and then fifth convolution layer. And after that, you have something called a fully connected layer, which is actually just a dense layer in your model. Okay, so here you can see that 37 million parameters are there. So there is like a lot of connections. So that will be like 9,216 into 4,096 connections. So this many number of inputs and this many number of outputs in this particular layer. Okay, and this is your second fully connected layer. From here you have like 16 million parameters. So that will be 4,096 nodes multiplied by 4,096 nodes. So imagine how much connections will be there. 4,096 by 4,096 plus 4,096 biases. So let me just do the simple math here. Let's see like how it is going to go. 4096 into 4097. So that is actually the thing. 16 million parameters. 16 lakh, sorry, 1 crore 7,000, sorry, 1 crore 67 lakh 81,312. These many number of parameters are there. So this is actually what we call 16 million parameters. And similarly, in the last layer, you have like 1000 classes. So 4096 into 4000, sorry, 4096 into 1000 plus 1000 parameter. If you do multiplication, then you will have like 4 million parameter. And if you take a sum of the whole weights and biases, you will actually have 60 million parameters. And those 60 million parameters, if you are representing each and every weightage and biases using 16-bit of floating point, you actually need 240 MB of size of model. Okay, so this is really huge. And maybe this is like looking very simple for you, but let's say how much time it actually take in each layer. The thing is, your convolution layers will be taking too much of time. So this is taking like 105 million flops, floating point operations. And this layer will be like 223 million floating point operations. And your dense layer will be having like only lesser amount of floating point operation, because the multiplication with the dense layer will be very simple, but the multiplication with the convolution layer, because you are going to like take an image and you are going to like move a filter along the image, so computationally it will be taking too much time. So that is why you can see that 90% of your model parameters are coming from your fully connected layer, and maybe 90% of your computation is actually coming from your convolution layer. So these two are like two major things that we want to optimize. One is actually dense layer, which is taking like lesser memory, sorry, huge memory, lesser speed. And then there is like a convolution layer, which is actually going to take lesser memory and like a huge speed. It means like it is very slow. Timing is actually very high. So we want to optimize this. So we will see like what are the different ways to optimize the neural network. So training a model is not really a big deal, but how we want to optimize it is actually the main motive of this particular research. Okay. Again, if you are running these models in a self-driving car, and imagine that the self-driving car is containing some GPU also, still, if your car is actually having a camera which can take maybe pictures in the rate of 30 frames per second, then if your model is actually taking for one image, if it is taking like 1 second to process 1 second of video, you will be needing like 30 seconds. Similarly, to process 1 minute of video, you will be needing half an hour, 30 minutes. So this is not a real-time requirement. This is not going to meet like the real-time requirements of a self-driving car. So how much faster the model should be if you want to do the processing like in real time. So in this case, what we want is like we want the model to be like having maybe like 33 millisecond. Okay, if your model takes only 33 milliseconds to process a single image, then it can process the 30 frames per second video in real time. Okay, so as soon as the first frame enters to the model, it will give the answer in 33 milliseconds. So there will not be too much delay. Okay, so you can have like maybe maybe few milliseconds of delay, but you cannot have like a few seconds of delay, because in the long term, if your length of your model is like length of your video is going to be higher, then it is going to take too much long time. Okay, so this is again one more thing that we want to like make the model into real-time ready. So what are the options? So how do we optimize? So you can actually like run the model in the cloud, because cloud contains like unlimited resources. Okay, so but there are like a few challenges when you try to like run the model in the cloud. Sometimes there'll be a network delay, that you are actually in a very remote area and you take a picture, and to upload the picture to the cloud may take some time. Similarly, there is a robot, and the robot is actually working in a very dangerous situation, maybe something within a mine. Okay, and there is no signal, there is no Wi-Fi. So if the robot is actually like sending the data to the cloud from remote areas, the robot cannot like send the data to the cloud because of the network delay. Okay, one more thing is like a power consumption. Imagine the same robot is actually there, and there is no like way you can actually do some recharge. So in that case, like even to upload the pictures and then download the pictures, that is also a problem. Okay, so to connect with the internet and then do some real-time streaming, you are going to lose some power. Again, one more thing is user privacy, that whatever the data comes from the camera of your robot, there is no like a security for the data which is going to be uploaded in the cloud. Okay, once you are streaming your data to the cloud, there is no guarantee that your data will be safe. So there is a concern about the user privacy also. Imagine that in your home there is like some kind of camera, surveillance camera is there, and it can detect some like maybe events in real time, but the camera is like uploading the data to the cloud. But if you're living in a home and your data is actually streaming to the cloud, so people will be always worried about the privacy of the data. So this is actually the challenge with the running the model in the cloud. But still many applications are actually running the model in the cloud only. But up to some level we can run the model in the cloud. But what we actually wanted, we want to like sometime run the model in the device itself. Okay, again, when you want to run the model in the device itself, these are actually the limitations. So we have like a RAM memory usage, because model may be bigger. Then we have running time, because maybe your cell phone is having like limited memory and then limited speed. Then there's a power usage. So after using the application for maybe 30 minutes, if your battery becomes like a 50%, then nobody will actually use that particular model. So again, download and then storage size, that becomes an issue. Okay, so these are like challenges, and we want to actually do the changes in the model, not changes in the cloud or edge devices. Okay, we want to actually play with the model so that it can cater to these requirements. So what are the like options? We have to play with the model, that is the only option. So we have to compress heavy models into small model. So how do you compress, how do we optimize the heavy models, bigger models into smaller models? So if you do that, then the advantage will be like we just need less space to store, and it will become energy efficient, it will become like low latency. So latency is like you give a data, something like image, and if your model is like a very deep neural network, so maybe the model is like a small model, but because of too many layers, you are having like a delay in the like processing the image, and the model is actually having high latency. So we want to like have a model with low latency. So again, computationally lesser expensive model we want. Okay, and when you want to compress the heavy model into a smaller model, this will be the drawback, the accuracy may reduce. You know why accuracy reduces? Because you are trying to do some changes, and those changes will be having a different impact in your performance of the model. So sometime maybe your model is like 100 MB and it is running like 1 second per sample, and since you are going to like reduce the like maybe size of the model by like 2 times, so 50 MB model, then now you can see that it is actually running in 500 millisecond. So previously the accuracy of the model may be 98%. Since you optimize the model, since you like perform some compression, the model accuracy may reduce like 94%. Okay, so obvious that this accuracy can never be like better than your original model. It will be like so original model will always have like greater accuracy than your compressed model. So this is the rule. But how much compression we want, how much accuracy we can lose, that is depending upon our situation. Okay. So let's see how to compress the model, how to optimize the bigger model. What are the different what do you call options available? So these are like some of the techniques, very famous technique in the literature. First one is called pruning. Second is like a weight matrix factorization, and the third one is like quantization. Fourth one is like a student teacher network, and the fifth one is automatic architecture search or neural architecture search. Personally, I have worked on weight matrix factorization, and I published a paper also related to this particular problem. Currently, I am working on this pruning methodology as a research like project. Okay, so let's start from the pruning. How the pruning is going to help you to optimize the model. So what do you actually mean by pruning? Pruning is actually just an act of removing some connection. Okay, so whenever you have like some connections and you're removing some of the connections, it is actually called pruning. You are actually removing something. So one example is in the campus you will have like a different trees. Sometimes you'll have bushes, and the bush has like grown really bigger. So what the gardener will do, they will just do like some pruning and then make the like bush into a like nice smaller version which is having a specific shape. Okay, so we try to like remove unwanted things and then make it into a structured one. So that is called pruning. And this pruning is actually happening in the human brain also, in our human brain. So this is actually the neurons in our brain for a gestation, which is actually just 36 weeks. And for a newborn baby, this is actually the neuron. And for a 3-month-old toddler, then this is like the neuron connection. You can see that some of the connections are becoming stronger. For 6-month-old baby, you are having like more stronger connections. For 2 year, you have like a much more stronger connection. Okay, so initially when the like brain is actually training for a young child, it will be like growing a lot of connections. Okay, so that is why the like child's brain is actually like very unstable. Kid will be like doing some random stuff because it is actually growing all the neurons in the brain. So you cannot expect the child to take a rational decision because it is actually in the training phase. You know, the beautiful thing is like for a 4-year-old and then 6-year-old kid, some of the connections which are actually not wanted, they actually started removing automatically. And that is actually called synaptic pruning. So the connection between the neurons in the human brain automatically like gets pruned depending upon the learning experience of the kid. Okay, so this is actually called pruning in the human brain, synapses pruning in the human brain. Okay, and the same methodology can be applied in the artificial brain, in the dense neural network, or in the CNN, RNN, whichever network you have. You can apply the same thing. You can actually remove some unwanted connections from the neural network. Okay, so let's see how we can do it. So after the training, let's say that this is your neural network, which is having like a certain number of inputs, which is like 3, and then you have a dense layer with the 4 connection, dense layer with like 5 connections, again one more dense layer with the 4 connections, finally 2 output nodes with the final layer. Okay, so what we can actually do, we can actually remove some unwanted connections. So if you try to do some removal of unwanted connection, that will be called as synapses pruning. Okay, synapses pruning. So how we are going to like remove it, we are going to just remove like this connection and this connection, which you think like not important. So you just remove it. After removing it, these matrices will actually become sparse, because since you remove the connection, the entry for this particular weightage will be 0. Okay, so if you are taking this particular matrix, like 3 input and then 4 hidden layer, so that will be like a 3 by 4 matrix, and the sum of the entries will be 0, something like 0 1 2 4 0 1 3 1 5 0, something like that. So it means for the first neuron of your input and the first neuron of your output, there is no connection. For the first neuron of your input and the first neuron of your output, there is a connection with the weightage of 1. So the matrix will actually become sparse. So what do you mean by sparse? There will be entries like exact zeros. And if your matrix becomes sparse, there is a huge advantage. We can easily store the sparse matrix. So this sparse matrix can be easily compressed. Okay. And one more thing is this sparse matrix can perform faster multiplication. Okay. So there is a library called a BLAST library. So let me just see like what is the expansion for BLAST. That is the basic linear algebra subprograms. So it is actually low level routine in your GPUs and your CPUs to perform matrix multiplication and linear operations in a faster way. So if you are going to like utilize the sparse matrices, then what we'll do, these sparse matrices can be compressed very easily, and the matrix multiplication can be performed very faster. Okay. So this is called synapse pruning. And how we can actually like prune it? What is the criteria? So the criteria is actually drop the weights below some threshold. Okay. If your weightage for any of the connections is actually like maybe lesser than 10 power minus 8, you can actually just drop the connection. Why you drop the connection which is having a lesser weightage? So please put your thoughts in the comment or in the voice also, you can let me know. So please turn on your mic if you want to let me know why you want to drop a connection which is having a lesser weightage. Why not the more weightage? So you can put your thoughts in the chat box. I'll just wait for maybe few seconds.
Participants, you may write in chat.
Yeah, from now onwards, we want the session to be like interactive, because like as of now, I just build the groundwork that what is the requirement for model optimization and the pruning, like we can do. So now you can actually think and then tell why you want to drop something which is actually below threshold. Why not a weight which is actually higher threshold? So you know the answer, but sometimes like you don't know how to get it out, or maybe technically you don't know how to say it, but that's totally okay. You can let me know. Less weights means less importance. Yes, Professor. Dr. Varsha, you are right. Less weight means less importance. So in the session 1 which I have taken, so we have already discussed that the weight or the connection actually shows how much importance the particular node is to this particular feature. Okay, weight means the importance of the connection, because model is not fitted 100%. Yes, that is also true that some of the weights will be still remaining small random values, and the model is actually maybe not trained 100%. It means not 100% of the connections are important. It means maybe only 50% of the connections are important, and rest of them are just lying in the whole process. It is just like a small random values, and initially you train the model with the small random weights, and after some time, after training also, if the model is actually having the same random weights, it means it has not even updated or learned anything. So even after removing these connections and making the model into much more compressible sparse matrices, the beautiful thing is your accuracy will not really drop too much. Maybe this model is 98.1 accuracy and this model may be 97.95 accuracy. Okay, there is a possibility. Sometime you compress the model into like a 2 times 50% smaller model, still you will get the similar accuracy. Or there are some cases, very rarely, that after removing the like some connections, your accuracy may improve a little bit. Okay, not always, but little bit. So you know why? Because these small connections which are not really important, they are actually run or lying on the like model, and then they are just doing nothing. They are just making chaos. If the model thought that this connection is really important, it would have already trained it. So why to have like some idle connection which are not really required? So that is actually the criteria. You can actually just drop out some nodes, sorry, some connections which are just below the threshold. Okay. So when you actually put a threshold and then take the weight, what we want to consider, we want to actually consider the absolute weights. Okay. Why absolute weights? Any idea? Somebody please comment like why we want to take only absolute weights of the model. So model can have like positive weightage and negative weightage. So why absolute weights? That is the question. So it's really good that I'm getting like good responses. Great. Sir, how do you determine the threshold value? That is a really good question, sir. That is really good. So for example, sir, you want to actually compress your model maybe like 2 times. The threshold will be dynamically set, that which threshold can actually remove half of the connection, then that will become the threshold. Or sometime maybe like you just want to like compress a model for a 98% accurate model. You want to like maybe compress a model which can just get like maybe 97% of accuracy. So you try to remove the connections till you get 97. Maybe this is your target accuracy, that I just can have a compressed model with this accuracy. This is my desire. So either it can be like how much compression you want. You want compression of 2x or 3x or 4x. Based on that, we can set the threshold. And there is no like formula to set the threshold. It will be done only during the experimentation. Yes, professor. It is actually trial and error, and we cannot just like remove all of them at one go. So initially we can just remove maybe 10% of the connections, and then after some time we can remove some more 5%, and then test the testing accuracy. And we are not going to like do anything. We just test the accuracy. Okay. To normalize. Okay. So Professor Rajiv has given that we can actually do some normalization. So why we actually like take absolute value? Sometimes weights can be like minus 5.7. Does it mean that it is like unimportant? Maybe your threshold is like positive 10 power minus 8. So this is actually like below that. Minus value is like below the threshold, right? So will you remove it? If your threshold is 10 power minus 8 and your weight is minus 5.7, will you remove it? So threshold value in itself could be a learning problem. Yes, sir. Yes, madam. Yeah, professor. So like setting the proper threshold is actually like a learning problem. So that is like learning a threshold for optimizing a network. That itself is a separate problem. Great. So like one professor has said that your threshold is 10 power 8 minus 8, and there is a like weight which is having minus 5.7. So like professor said that we can actually prune it. Nidhi Dahale. Professor, we cannot prune it. That is actually the like proper thing, that we should not actually prune a negative larger weightage. You know, weights can take like a positive value as well as negative value. So if it is taking like 5.7, it is correlated like 5.7 times the input. If it is minus 5.7, it means this particular connection is actually negatively correlated. Still there is a correlation. Okay, it is not zero correlation. Still there is a correlation. So the weight can be positive as well as negative. So whenever you try to like set a threshold, you have to set a threshold for the absolute weights, because weights can be positive as well as weights can be negative. So negative weightage may be like means there is a negative correlation. Positive weightage means like a positive correlation. But what we actually want is like a lesser correlation or zero correlation. Okay. Yeah. So weights can carry from like vary from -1 to 1. Yeah, professor, that is really like a good question. Like what will be the range of the weights, -1 to 1, or like generally the thing is like the weights can range from -infinity to +infinity, but it won't really like take too much of range, like maybe weight is 256, 327. So it will not take this much of values, because when you are going to train the model, you are going to randomly initialize the weights with a small random value. Okay, small random value means like -5.6 into 10 power -3, 5.3 into 10 power -4. So you are going to like take a small normal distribution and then simulate it. Okay, so small random distribution with zero mean and maybe a standard deviation of 10 power -3. Okay, then you can actually simulate some small random number, and there is no way that these random numbers are going to be learning with the larger weights. Okay, on the way they will actually run train and then like converge in weights which are just small numbers. Okay, but the theoretically weights can range from -infinity to +infinity. Okay, but sir, we are normalizing the model, so values may vary from 0 to 1 or -1 to 1. We are actually not normalizing the model, sir. We are actually just like removing the unwanted connection. Okay, sir. So the thing is like we are not going to touch the connections which are actually like having strong connections. We are going to just remove the weaker connection, which are actually having weaker weightage. Yeah, so that is also like one more good analysis. What we are going to do with the connections which are already there, which we are not removing, we are not going to touch that. So the connections which are already there are going to be there. The connection we are going to remove, that will be set to 0. Okay, instead of saying like a 10 power -8, you are going to just say remove it and then 0. Okay, so there'll be some small changes in your model because of removing small connections, but you try to do it until you get a like a decent accuracy or a compression rate. Okay, so this is a very simple case of synapses pruning in the neural network, and the criteria will be threshold. Okay, so the pruning will like really work, because if you just take the histogram, if your whole model, the weight histogram, most of the weights will be like just near the 0, and some of the weights you can see that they are near 4 and then they are near -4. So if you just plot the histogram, the probability distribution of your weights of the model, this is how it will look like. So it means the majority of your model parameters are just staying nearby 0. Okay, and this is actually a big number. If you just remove all these connections and then set them as 0, then you are going to compress your model in a very nice way. Okay, so we can actually ignore connections which are smaller in the magnitude. Okay, all right. So there are like a few types in the pruning. One is actually called fine pruning, which you have done already, pruning the weights or the connections, or we can call it like a synapses pruning. So second type of pruning is actually called coarse pruning, where we are going to prune the node itself. So what do you mean by like pruning the node itself? For example, you have like this, like all connections are there, and we found that this particular node is actually not important. So we are going to keep this and this, we are going to remove it. So after node pruning, what will happen is like your model will actually become like this, like all dense connection will be there. So what will happen, this 3/4 matrix, weight matrix will be gone, and 4 by some n nodes, so 4 by n will be there. So that is going to be converted into like a 3/3 matrix and then 3 by n matrix. So we are going to like remove all the incoming nodes to this node, and we are going to remove all the outgoing nodes. So this is called node pruning or coarse pruning. So if you want to see larger effect, you can actually do some coarse pruning, that you remove the node itself. Okay, and we will see like how do you remove the node, what is the criteria, so that we will see. There is one more type of pruning, So this is like what is the granularity of the pruning? Based on the granularity, we can have weight pruning or we can have node pruning. Okay. Similarly, if you are working with the CNN, this coarse pruning will be done in the not in the load level, it will be done in the filter level or in the kernel level. So that will be called filter pruning. Okay. So in the dense neural network, we are going to call these things as nodes, and in the CNN, we are going to do it with the filter pruning or kernel pruning. Okay. So based on the granularity, this is like two types, fine pruning and coarse pruning. And based on the mode of your pruning, whether you want to do some extra training or not, you can call it like a static pruning. Pruning is done after the training, or something called dynamic pruning, where pruning is actually happening during the training itself. Okay. So what we are going to do in the static pruning, you try to take a model, empty model, you just train it, and then you just prune it. What you will get is a smaller model. Okay. And in the dynamic pruning, what we are going to do, we are going to take an empty model, we are going to train it. While training, some of the nodes are actually like not learning anything, some of the weights are actually still near zero. So what we do, we remove them. Or maybe some of the nodes are actually not learning anything, we remove them. Then what we do, we actually train it again. Even after training it, maybe you find some more nodes are actually still having weights which are like lesser than some threshold. So again, you remove it and then you retrain it. So that is actually pruning during training. Okay. So that is something like you are trying to remove the connections of the node or connections of the maybe between the nodes, either the synapses or the nodes during the training itself after some few number of epochs. Okay. So you train the model for like 1 hour and then you do some pruning. With the pruned model, again, you try to train the same model, and then after 1 hour, you try to do one more pruning, and you try to do it until you get a good accuracy, 98%, and then a smaller model, maybe 100 MB. Okay. So which one is better, static pruning or dynamic pruning? So you please put your thoughts, which will be better, static or dynamic? Please do some voting. Which will be better? Dynamic. Okay. So one professor has said that the dynamic pruning will be better. Dynamic mix. Okay. So again, that is just a perception, like how you are trying to do. So you can just take an example that somebody is actually learning some bad habits. Okay. That is not should be like that should not be learned, but somebody is like learning all the bad habits. So what he's actually doing, like he is going through like all the things, and then he become like something else. After that, he is like cleaning himself. So he is like going to remove all his sins. So he is becoming a cleanly person. So that is like after the training, you try to do some pruning to yourself. You become a like a clean guy. So dynamic pruning is something like this guy is actually like learning some bad habits, and then while learning the bad habits itself, he is like trying to clean himself. Okay, he is trying to like remove some part of his like ugly thoughts while learning for another like bad habit. Something like he dynamically like remove it, dynamically correct it. Okay, so something like experience something and then learn the lessons. So this is like learning the lessons during the experience itself. Okay. Static pruning is like do everything, after that you try to do the pruning. Dynamic pruning is like do the pruning while during the training itself. So again, it depends upon your comfort level, what you want to do. Sometimes you want to like train a really good model which you are focusing for a good accuracy, and after that you just try to like do some pruning and then play with the model. That will be better, and this will be taking only lesser time. So time will be like really lesser because you are not going to like stop the training and then prune it and then retrain the training. That will become like more hectic. But if you are very comfortable in training the model in better way, this will be taking long time, but this will be very efficient also. Okay. But most of the time what people used to do, they try to take a model, train it, they try to remove some connections, prune it, and then you have like a smaller model. The smaller model, before they try to deploy it, they'll try to do the training one more time so that the remaining connections will be like fine-tuned. Okay, so this will be like called post training, or like fine tuning the model. Okay, after you do the pruning, you try to fine tune your model a little bit so that whatever the damage you have done, that will be corrected. Okay, so that will be done only once, but in the dynamic pruning you are going to like do it again iteratively. So any questions? Yeah, so again, like depending upon your like time limit and then resources, you can decide whether to do static pruning or dynamic pruning. Okay, so now let's see what are the criteria for node pruning. If you want to like prune a node, what criteria we can have? So one of the criteria is actually weights. So take an example. Like all connections are there, you can actually consider weight as a particular criteria to remove a node. So we want to actually do node pruning. So if you want to remove a node, we can actually check whether this node is actually having strong incoming connections as well as strong outgoing connections. Okay, so what you can do, you can actually take absolute sum of all the incoming weights and absolute sum of all the outgoing weights. Okay, and you try to take a sum of all these four nodes, and the first node is having like maybe the absolute sum 2.3 into 10 power 2, second one is like 1.7 into 10 power minus 3, third one is like 1.7 into 10 power 2, fourth one is like 1.35 into 10 power 3. Okay, so the thing is, you take like absolute sum of all the incoming weights as well as all the outgoing weights for all the four nodes, and this is the first, second, third, and fourth node. You can see that the second node is actually having weak incoming connections and weak outgoing connections. So the thing is, this particular node is not really contributing that much for the whole network. What we can do, we can just remove it. So we can just remove this node. So what will happen, all the incoming three connections will be gone, plus one bias will be gone, and all the outgoing connections will also be gone. So that will be physically removed. So this node pruning is actually done in a physical level. Okay, but if you are like removing the synapses connection, you are not going to remove the physical connection. We are going to set the weight as 0. Okay, but still the entry will be there in the matrix. It will be a sparse matrix, but here the entire weight matrix is actually going to be changed. So one criteria is actually the weights. Okay, and the second criteria is actually the activation. So what do you think, which node we can prune? The node which is going to be activated a lot, or the node which is going to be like activated only for few samples? So please put your thoughts, which node we want to prune. If you want to consider activation as a criteria, high activation or low activation we want to prune. So weight, everybody can agree that the weightage has to be higher. Low activation. Okay, Dr. Kamal Sethi, you have given correct answer. Only for few activation prune that. Yes, professor. So you are right that when the particular node is actually activated seldom, it means most of the time this particular node is being idle and we can just like remove that thing. So how do we like get the activation, whether the node is like giving activation or not? How do we get it? So weight, you can directly take it from the model, from your weight matrix. So from the weight matrix, you can take which ones are like smaller, which ones are higher. So how do we take the activation? It will not be available with the model. Any idea? How do we get the activation? Or what we need to get the activations of the model? So how do we evaluate it? Okay, I'll give a clue. For activation, you need to run the model with the samples. What are those samples? These are actually your data set samples. Okay, so what you can do after training the model, you take the training set of the model and then run the model for the entire data set. You give one image, take the activation for each and every layer, then you just store it. You run another image, take the activations, and then you just store it. Again, the activation for all the nodes will be like a matrix. For one layer, it will be 4 by 1. For other layer, it will be like 3 by 1. So you can actually like run for like 10,000 samples and then create a matrix of like for these 4 nodes, you can take like 4 by 10,000. And you can take like the absolute sum of all the activations, and whichever node is having a lesser activation, we can just prune it. So maybe statistically the activation is like very less for a particular node. This node, maybe it is a lesser important node. So what do? You try to remove it. Okay. So why we take the absolute activation? That is the next question. So when we take the weights, that was the absolute weight. When you take activation, why you take absolute activation? Yeah, professor, somebody raised the hand, it seems. If you have any doubts, then please let me know. We can clear it out.
Those who have doubt may write in chat.
Yeah. Okay, any idea why like absolute activation? That is a question. Why absolute activation? Why not just activation? So for weightage, we have take the absolute value of the weightage, because positive weightage means like positive correlation, negative weightage means negative correlation. Both are important. Similarly, like why we are using like absolute activation? So the same case, that positive activation means you are actually having a higher activation, means high similarity. Similarity is like really high. And when you have a negative activation, it means there is a less similarity or negative similarity. You can call it like dissimilarity. So that is actually the negative weightage. Okay. So there are many activation functions like linear. The range of the linear will be like minus infinity to plus infinity. So if you're training the model with the linear activation function, there is a possibility that you will get a negative activation also. So if you are using like a sigmoid as activation, then your activation will be in the range of 0 to 1. So again, here the value will be always positive from 0 to 1. In that case, you don't need to take the absolute values. If you're using like a tan h as an activation function, then you have values from minus 1 to 1 in the activation matrix. So here you can take the absolute value of your activation, and you have one more called ReLU, rectified linear unit, that will be giving activation from 0 to infinity. So again, you don't need to take the absolute value. But if you are using linear and tangent H, you can actually use absolute activation statistics to find which nodes are actually not important. Okay. All right. So there is a third criteria which is actually seldom used, but it is like a very, very, very efficient. It is actually like going to consider the cost to the model. What do you mean by cost to the model? Very simple. So here is a neural network with like 4 by 3, 3 by 1. So what do you do? After the training, your model is actually giving 98% accuracy. Okay. So what do you do? You prune the first node, you remove the first node, then you check like after removing what is your accuracy. So if your accuracy is like maybe 97.5, it means this node is actually contributing 0.5% for the particular network. So now what you do, you keep this node and you remove this node, only this node. So these two will be there. Only the second node will be removed. After the second node is removed, your accuracy becomes 93. It means it is a very important node. After removing it, your accuracy drops in a very larger number. So you just like try to note your accuracy drop. So finally what you do, you keep this node and you keep this node and then you remove this node, only this node. Then you check, then the accuracy becomes like 91. It means this third node is also very important. So now you like got the accuracy drop, which node is actually having high accuracy drop and which nodes are having lesser accuracy drop. So this particular scenario says that the first node is actually having no effect in that after removing it. Okay, no effect in the accuracy. So what we can do, we can just remove this particular node and then keep rest of the two nodes. Okay, so this is actually called cost to the model, where instead of the accuracy, you can just keep the loss or the cost function. Okay, cost will be like 1.3, something like that. So that can be one criteria. Difference between actual and the predicted. Yeah, sir. Yeah, that is actually the cost. Cost, COST. So if your model is making a lot of mistake, then the cost of the model will be really higher. So similarly, like if your model is actually having some nodes and after removing those nodes, if your accuracy is not dropping, then that particular node can be removed. So now there is a polling. Which one of them is actually like better in your opinion? Which is better in terms of like efficiency and then speed? Which is better? How much faster you are doing the pruning and how much efficiently you are doing the pruning? Which is better? So weight pruning is going to just consider the magnitude of the weights. Activation is actually again going to take all the data set and then run it and then take the activation. Okay, so Dr. Vasha has said that cost to the model, how much cost the particular model is like contributing. So maybe that is like one thing. So the thing is, it depends upon the situation. If your model is small, then this can be a better option because you can actually try with all the possibilities. Yeah, so two professors like Madhavi and Alka Patil, so they have said that the weight is actually better. So they are saying like weight is better because like it is very faster. After training, you don't need to do anything. Just take the weights of the model, take the absolute value, and you just like prune it. Okay, so it is faster sometime or most of the time it is efficient also. So many people, or we can say like 90% of the people, they actually just do with the weight pruning only. And this is actually computationally will take a lot of time. because imagine a like a 4096 by 4096 matrix. Here you need to prune. So you need to actually like remove one node from 4096, take the accuracy, again remove one node from the 4096, second one, take the accuracy, only remove the third one. So you will be like doing the pruning for 4096 times, then you are going to take the best out of it. So that is going to take a lot of time. If your model is really small, you can actually do it. But in reality, deep neural network, all the nodes and layers will be having huge number. So this is like seldom used. But in terms of like really good efficiency, this is really efficient, but not in terms of the speed. Okay, activation is also another thing that this is also used in many scenario, especially if you are doing transfer learning. Transfer learning means you have already taken a trained model and then you are going to train it for a new data set. Okay, so sometimes some connections will be there which are having like larger weights, but for new data set they are not really needed. Okay, so those connections cannot be removed using the weight pruning, but those connections can be removed only for analyzing with the new data set. So especially if you're working with the transfer learning, where you take a trained model and then try to fine tune the model for a new data set, in that case, weight pruning will not work because maybe even trained nodes are not going to be used for a new data set. Okay, in the new domain, they are not going to be useful. So in that case, you can go for the activations. So it depends upon the situation. All right, so this is really cool that pruning can be done in node level. So the same criteria can be done for the filter level also in the CNN. If you do filter pruning in the CNN, so if you are like having a CNN model, convolutional neural network model, and you are going to remove the filters, what is the benefit of it? Are you going to have good speed, or are you going to have smaller model size? Which one? You have to choose between two things. So if you are doing with the filter pruning in your neural network for images CNN, you are going to gain speed or like memory, which will be like optimized mainly. Memory. Okay, so Professor Madhavi has said memory. Any other thought? The filter pruning, what about the filter pruning, whether it is memory versus speed? So the answer is actually speed only. So we'll see why. So in your CNN model, the parameters are actually more for your fully connected layers, and the parameters are going to be less for your convolution layer. But computation wise, your convolution layers will be taking like too much of computation because they are going to do redundant repetitive multiplications, and your dense layer will be having advantage of lesser speed, like a lesser computation. Okay, so 90% of your computation is actually done in the convolution only. So when you are trying to like prune with like instead of 256, if you are reducing into 200, so it is not going to make too much change in the memory. It is going to make a really good change in the speed only. Okay, so if you are trying to like maybe prune nodes from the dense network, it is going to actually benefit you in the memory rather than the speed. Okay, so speed it can reduce, but only the memory will be like reduce a lot. So dense layer is actually for memory, convolution layer it is actually for speed. So please keep that in mind. Okay, so after the magnitude based pruning method, magnitude means like a vague magnitude, and iterative pruning and retraining. So this is like done in the particular paper. So they have iteratively like pruned the model and then retrained the model using magnitude as a criteria. So you can see that the fully connected layer, so they have kept like only maybe like just 10% of the entire fully connected layer, and these are the only remaining parameters, and these are actually pruned parameters. And you can see that they have actually pruned almost like from 5 million to 60, almost like 55 million parameter they pruned from the last layer, and they kept only like 5 million parameter, and they reduced the model size into like almost 10% of the original model, and still they got the same accuracy. Accuracy of the model is actually sometimes better, and it is like almost equals. Okay, since you are doing like a retraining also, you are going to like gain the accuracy that you lost. Okay, so retraining sometimes is becoming like a very essential, because you try to like modify the network to compensate the damage you have done. Okay, so this was like one of the very famous work which has done the iterative pruning with the retraining. Okay, okay, so this is how the sparse matrix weight will be. So there is a package called TF-Lite in the TensorFlow. So TensorFlow is actually a platform for doing the deep learning coding in the Python. So in the TensorFlow, there is something called a TensorFlow Lite, TF-Lite, and this particular package deals mostly with the neural network optimization and fine tuning. So the TF-Lite model actually provides pruning, which is actually connection pruning with retraining. Okay, synapses pruning with retraining. So that is what they actually provide in the TF-Lite package. So it is actually from Google, so it should be good. Okay, all right. So next we are going to one more topic, which is actually called weight matrix factorization. What is matrix factorization? Matrix factorization is the operation of converting a bigger matrix into like a smaller matrices. Okay, so how do we do it? So we have a weight matrix. Instead of removing anything, so we are going to like take the weight matrix. So maybe like 15 nodes in the input and 15 nodes in the output. Your weight matrix will become 15 by 15. So what we are going to do with this weight matrix, we are not going to remove any connection. We are not going to remove any node. We are going to like do some decomposition to the weight matrix. Okay, we are going to factorize the weight matrix. Okay, so to factorize the weight matrix, there is like a lot of techniques. So there is a lot of matrix decomposition methods available. One of the famous matrix decomposition method is actually called the SVD, singular value decomposition. So what will happen? A matrix W of size maybe n by m, or like maybe m by k, can be decomposed into like three smaller matrices, like U, V, and then this S. Okay, so S is actually a diagonal matrix which is in the middle. So all the other entries will be like 0, and U and V are the other two matrices. Okay, so how we can actually like do a compression with the decomposition, that is what we are going to see. Any doubt with this? We just like try to decompose a larger matrix into like a smaller three matrices, and with these three matrices we are going to do some compression. So let's see how to do that. So there is a technique called a truncated SVD or truncated singular value decomposition. What we will do, we take a like a weight matrix of size 16 by 8. So after applying the SVD, then your matrix will be like decomposed into U matrix, which is like 16 by 8, and then S matrix is actually the diagonal matrix with 8 by 8. So here black means like all of them are actually zeros, and finally V matrix with the 8 by 8. Okay, so now you try to do USV multiplication. 16 by 8 into 8 by 8 will become like a 16 by 8. 16 by 8 into 8 by 8 will become 16 by 8. Okay. So if you do matrix multiplication, then the original matrix will be reconstructed. Okay. So that is a property of your SVD, singular value decomposition. Okay. So this is vanilla SVD. Vanilla SVD means like a naive SVD where your entries will be like having this many number of numbers. So we are going to like truncate these matrices. Truncate means we are going to like remove some of the things in the matrix. So how to do that? So in the property of SVD, these entries are very important. Similarly, like here, these below entries are very important. And these above entries are not really important. Okay. Similarly, these above entries are not really important. And similarly, these diagonal elements are not important. These diagonal elements are important. Okay. So what we can do, we can actually remove few of the columns from here, and we can remove like a few of the rows from here, and we can remove few of the singular values from here. So if you just remove like maybe 2 rows from here, 2 columns from here, 2 by 2 matrix from here, then your singular value decomposition will become like 16 by 6, 6 by 6, 6 by 8. Now the thing is, if you do multiplication again, 16 by 6 into 6 by 6 will become 16 by 6. 16 by 6 into 6 by 8 will become 16 by 8. You will be reconstructing the same original matrix. So that will be W cap. Now the question is, are we going to lose some any information? Yes or no? So with the truncated SVD, are we going to lose some information, or is it going to be like not having any effect? Anyone? Okay, so Professor Patil has said that we are not going to lose some information. So the thing is, okay, so Dr. Varsha has also said that there is not going to be too much information loss. So it is true that if you are removing like only few columns and then few rows, or like a few entries, we are not going to lose too much. Maybe with the original matrix, your accuracy was 98. With the decomposed matrix, if you are like reducing it, then your accuracy will become 97. Okay. So the thing is, if you decided that I will keep only 2 rows, then what will happen? So it will become 16 by 2 plus 2 by 2 plus 2 by 8. So just count how many number of parameters are there. 16 by 2 will be 32 plus, if it is a square matrix, 2 by 2 will not be like, we don't need like 4 value. We can just represent with just 2 value, because other entries are actually just 0 only. So this will be 2, 32 plus 2, and 2 into 16, sorry, 8 will become 16. So that will be 34 plus 16 will become 50. 16 into 8 will become 128. So instead of using 128 floating point numbers, this entire matrix can be converted into these small matrices: 16 by 2, 2 by 2, 2 by 8. And this will have only 50 floating point numbers. Now the thing is, we have compressed the model 2 times. And maybe with the truncated SVD, if your accuracy is still good, maybe instead of 98 you are 97, then this is really a good compression technique, that we have reduced the model size 2 times, but the accuracy loss is only 1%. Okay. So sometime when you are trying to deal with larger matrices like 4096 by 4096, this technique will be really useful. Okay. It will try to remove a lot of redundancy from your bigger matrix, and then it will convert into like smaller matrices. So again, how much to truncate? Any idea? How do we truncate? How much to truncate? So we can dynamically do the truncation. You remove like one layer, then check the output. You remove like one more, check the output, one more, check the output, and you try to find a elbow point where your accuracy drop is too much. Then there you try to stop the thing. Okay, so setting the how much truncation you want to do it in the SVD or the USV matrix is actually depending upon your trial and error. So you start with like a last few and then try to move from here to here. Okay, and here you need to start from upper to here. So these entries are very important, we should have it, and these entries are really important, we should have it. Okay, so this is actually called matrix factorization. And one more thing is, if you are doing this kind of matrix factorization for filters in your CNN, the truncated matrix will be having like a faster computation than your non-truncated original CNN filters. Okay, your original CNN filter will be like a 3D matrix, which you have to multiply with one more 3D matrix. Okay, but if you try to decompose this 3D matrix into like maybe 3 2D matrices, then the multiplication speed for these 2D matrices with the original matrix will be comparatively lesser. Okay, so if you are applying the SVD technique for dense network, you are going to reduce the size. If you are applying this truncation technique for the CNN, you are going to reduce the speed. Okay, speed is going to be boosted up. Okay, so this is another really cool technology related to the neural network optimization. Okay, so there is like one more third criteria, which is actually quantization. So what we do in the quantization, weights are like in the range of -infinity to +infinity. So what we are going to do, we are going to quantize our weights into some fixed range. So if your weight is actually greater than or equal to 0, you are going to say that it will be 1. If your weight is less than 0, you are going to say weight is going to be -1. Okay, and the thing is, these two values can be represented using 1 bit. Okay, just a binary matrix. So if you have a matrix full of like real numbers, you can just create a binary matrix like 1 1 0 0 1 1. Okay, and in reality this 0 will be taken as -1, and this matrix can be easily stored, and you are going to have a model which is actually 32 times smaller than this. Okay, but the problem will be the accuracy will be dropped by 20%. Okay, since you are going to convert your regular matrix weight into like a binary matrix like this, your accuracy will really drop a lot. Okay, but the thing is, 32-bit representation of a floating point will be now represented with 1 bit of these quantized weights. Okay, so this is called quantization, and if your model is using like a single bit like 1 or 0 to represent the weights, then those are actually called as binary networks. So this particular technique is actually called network binarization. Okay, so this is like a very famous technique. Again, if you try to compromise your accuracy, then this will be really a good technology. Okay, but these days people seldom use it. It is just a like a adventure kind of method. So there is no practical usage here. So there is one more thing, that is actually floating point representation. Usually when you are training a model in your Python environment, the weights and biases are going to be represented using 32-bit floating point representation. So what people used to do, sometimes they try to like do 16-bit floating point representation. Okay, or sometimes they try to do 8-bit floating point representation, where 3 bits will be for the exponent and then 5 bits will be for the like fraction. Okay, So if you are converting a model which is represented using 32 bits, your accuracy may be 98. Since you are going to represent your 32 bits, converting them into like 8 bits, now your model can maybe like go to 93%. But the advantage is you are going to reduce the model size by 4 times. So if you convert into 32 bit to 16 bit, the compression will be 2 times, but accuracy may still remain the same because there is not much difference between 32 bit and 16 bit in the floating point representation. You are not going to lose too much of information, but when you try to compress into 4 bits, you are going to lose too much. Okay. So there are other methods also. Instead of 32 bits, people try to do with the 4 bits also, 4 bits of integer value. Instead of 4 bits, 32 bits of floating point, they try to do with the 4 bits of integer. Sorry. Any doubts you have, please let me know. Otherwise, we can move on to the next approach. So these techniques are collectively called as low precision techniques. Okay. Representing the number with the low precision. So there is like one more technique which is like very similar to what we have seen. So that is actually called 8-bit uniform quantization. So what we do is like you try to like sort all the weights from like a minimum towards the maximum. Okay, you just like have the weight matrix as a vector and then sort it out. Then what you do, you uniformly divide them into like 256 equal divisions. You try to like do divisions like 256 equal divisions. Then what we are going to do, we are going to like round off the weights to the nearest point. So if you're like maybe in the division, if your weight is actually here, now you are going to say that the weight will be now this value. So this value will be like 10.7, this value will be like 11, this is like 13, this is like 15. So if your weight is like maybe 12.9, you are going to say that I'm going to take 13 instead of 12.9. So these 256 different bins can be represented using 8-bit entries. Okay, using 8-bit entries, you can have a table which is going to say that for the first bit or for the 0, what is the minimum number? You can say like 0.0001. Similarly, like 0.00000001, we're going to say like 0.500. Okay, so you can divide your entire weight distribution into like a uniform 256 bins. Then anytime you want to represent any number, you are going to like go to the nearest bin value, and these 256 values will be represented using 8 bits. So we all know that what is the capability of the weight bits. Okay, so now the advantage is instead of representing any floating point value with 32 bits, you are going to represent them with just 8 bit, and this will be 4 times faster. But what about the accuracy? Is it going to be like affected, or any idea whether it will be affected or not? Okay, we got one reply. Not okay. So sometimes there'll be some effect. If your weight distribution is really cool and there is not like really that much variation between the weights, it is not going to be affected. Okay, for example, maybe your range of the weights are like from -1 to 1. So if you are dividing this -1 to 1 with like equal distribution, so there is not going to be too much of variation between the weights. Okay, imagine that your weights are in the range of 100 to 100 and you are trying to do the division. So even a very simple, small like changes will be having a larger effect in your model. So that is why it depends again upon the range of your weights. What is the minimum and maximum value? Okay, we got one more reply. Yeah, so Professor Vinod has said that yes, it will be affected. But please keep in mind that whenever you try to do some optimization to the model, obviously there is a effect. Okay, but we try to reduce that effect. So the thing is, speed and accuracy is always a trade-off. If you are trying to improve the speed, you are going to reduce the model. When you reduce the model, you are going to get a lesser accuracy. So this is a trade-off, that the speed versus accuracy. When you try to improve the speed, you have to compromise on the accuracy. And when you want to improve the accuracy, you have to build a bigger model. When the model becomes bigger, then the speed will become slower. Okay. And cost, yeah. Accuracy and cost, speed versus accuracy, these are actually trade-off. Okay. All right. So this is again, quantization is really one good topic. So in the CNN convolution, there is something called a fire layer. So I think I can skip this part because it is not really a compression technique, but it is just a way to reduce your computation in the convolution. Okay, so I don't think many people will understand this. So let me just skip this part of fire layer, and the global average pooling also, let me skip it, because this too requires knowledge in the convolutional neural network. So I am just going to skip it. Okay. All right. So one more technique which is actually very famous. So maybe I will revisit it later. So that is called a student teacher network. Okay. What is a student teacher network? So let's see, in the neural network, you try to build different models. So this is input, and this is the output that we want to have. So single hidden layer network will have a single hidden layer, and then it will try to map your input to the output. So this is called SNN, single hidden layer or single hidden layer neural network. Then we have deep neural network, where your number of nodes are really large, and the number of layers are also really large. So again, the output is the same, input is the same, but the structure is actually different. Then sometimes you have images, and you try to do with the convolution. So what you do, you try to do some convolution, then you have a fully connected layer, like that. So again, input will be same, output will be same. Okay. So if you see, the common thing between all these models are actually input and the output. Okay. So what we are going to do in the student teacher network, for any problem, we are going to learn a teacher model, which is actually really big. Okay. And what we are going to do, after training the teacher model, which may become a 98% accurate, we are going to create a smaller model, which is a student model, that is going to mimic the larger model. So it is going to mimic the larger model with a comparatively lesser number of nodes and layers and lesser number of parameters. Okay. So how do we do it? So we learn a teacher model, which is really big, and then we try to create a smaller model called a student model, which is going to mimic the teacher model. So how do we do this mimicking? Imagine that this is your teacher network, training one. So what is happening is you are training a teacher model, that this is going to find the target, this particular place in the image. Okay, this is the target, and this teacher model will have a comparatively larger number of nodes and larger number of layers. Okay, so the training one, you try to train the teacher model with these kind of targets. Okay, so then what you do, this is your teacher model's output for the training example. So this is your teacher model. Now what we are going to do, whatever the teacher model has predicted, you try to give it as a target to the student model, which is actually having comparatively lesser number of layers. Okay. So the thing is, let me put it like a much more better way. If this is your teacher model, which is giving like this particular output, so to get this particular output, this is really important. Okay. And what you do in the student model, you try to predict this as a target, because this is going to help you in predicting the output. Okay. So now, keeping this as a target, you are going to train a smaller model, comparatively smaller, with the same input. And the teacher's output will be the target to the students. So whatever the teacher is like trying to predict, the students also predict the same. Okay. The actual target is this. This is the actual target, which is actually Y. And this is actually predicted by your teacher, which is actually Y prediction of the teacher. Now the prediction of the teacher has become the target to the student. Now this can be easily trained with comparatively lesser amount of nodes. Okay. So what you do, maybe the student model or teacher model is giving like input like 1, 2, 3, 4, 5, 6, 7. Then the output of the teacher model is like 1, 0, 0, 1. The actual output is like 1.100, 1.1. Okay. So instead of predicting this, you try to predict this. Okay. Not necessarily the last layer, but maybe the layer before that particular layer. So what do you think about the student teacher network? You try to mimic the teacher's behavior. So maybe to predict the actual output, you actually need this layer and the features. Okay. And maybe the student is trying to mimic the same functionality. This functionality is like predicted here. And after some time, you don't need to have the teacher model. You just need the student model, because you already have a miniature model, which is going to mimic your teacher. Okay. So any doubts regarding this? Again, please do understand that this student teacher network is actually just an ideology. It is just an ideology of how we can actually build a bigger network and then one more smaller network to simulate the same results, which will behave like the same. So again, it is just an ideology. Okay. But how you want to implement it, it's up to you. So there is no like a specific commands for running the student teacher network in the Python or R programming or MATLAB. This we have to implement. Okay. So one more famous technique, which is actually in the very recent days, is called neural architecture search. And this will be actually called as AutoML, automatic machine learning, where you try to like just give the data and the model will automatically search for the architecture, best architecture to give a good accuracy. Okay. So you will just give a data, and what the model will do, the neural architecture search mechanism will try to like take all the possibilities of the model. Okay. So it will check with like a different combination of filters, different combination of layers, deep layer, small layer, medium layer. You can see that some of these models are having lesser accuracy, 83, 78, 64, 54, 69. Okay. And maybe one of the architecture that is going to try, it is going to have a better accuracy of 97. So this architecture was actually searched by the model automatically. So there is like a mechanism which will be running in a base network. It will try out everything. Okay, all we need is just a pre-processed data and then a base network. You just need to tell that I want to build a network like this. It will try every combination. It will try like maybe with the 5 nodes, with the 16 nodes, with 32 nodes. Okay, sometime it will like remove a layer and then directly connect with the other node. Okay, so this is called a neural architecture search. Is NAS similar to the self-organizing maps? I'm not really sure, Professor. SOM I try to study a little bit, but I couldn't. But this one is actually guided. So guided means when the model is actually trying to like train with the 16 node and it is going to like a 32, accuracy of 16 node was like maybe 90, and when increasing like 92, so you are actually giving a guidance that increasing this is going to increase accuracy. The next architecture that it will search will be involving 64. And if it is going to be 94, then it is going to check with 128. If it is still 94, then there is no change in the accuracy. So it will never check the 256. It will not check. Okay. So the architecture search will be guided based on the previous results. So with one layer, it will search maybe one layer, the accuracy is 60, 2 layer accuracy becomes like a 70, 3 layer 90, 4 layer 91, 5 layer again 91. So what we need to increase now is not the layer anymore. Maybe node you try to play with. Okay. So this neural architecture search is actually very time consuming, and you need to run these models in big supercomputer. Only then you will get the results maybe after a few months. So this will be running for 20,000 times, like all the combinations, permutations will be tried, but not random, but guided way. Will NASA do optimizer? NASA or NASA? So neural architecture search is just a terminology, like how you are going to search the best neural network out of all the possibilities. Okay. So that is actually called as AutoML, and when you give a data to the AutoML will try to like analyze the data and then try to find the best architecture. So it will both like do the training and then like it will do the deployment, and then it will actually like serve the application with the like model, and it can actually create a like REST API also. So your model can be running in the cloud, and then you'll be calling the model through the API. Okay. So AutoML is actually a technology and architecture. So whenever you have time, you please like try to explore it. So NAS do the optimization. Yes, sir. NAS will actually try to search for the best architecture. NAS will not do any optimization in terms of like, but NAS will like try to find the best architecture, like simple small architecture. So here the NAS will not be trying to like prune a pre-trained model, or it will not be like trying to optimize a trained model. It is going to train a new model. Okay. So this neural architecture search, sometimes we don't know like what is the simplest or the simple model which is having a good accuracy, because we don't want a deeper model which is having good accuracy and a very lesser speed. We want just a simple model which is having good accuracy as well as good speed. It is in fact doing optimization, but in a different way. Okay. So if you have worked with the Keras in the Python, there is like a package called Keras. So there is a one more package which is called AutoKeras, and the AutoKeras is actually going to work in the similar manner, that you try to give the data set to the AutoKeras, and the AutoKeras will actually try with the different model and will give the best model. Okay. So the syntax for the AutoKeras will be looking like this: import AutoKeras as AK, and the model equal to AK.image classifier, verbose equal to true, model.fit, model.final fit will actually give the like a final model. So when you do model.fit, it will actually try to find the best architecture. So one sample of neural architecture size is actually AutoKeras. If you are working with the Keras already, then you can actually work with the AutoKeras. So there are different frameworks in the Python for doing deep learning. So one is TensorFlow, one is like PyTorch, other is Keras. So I don't think like we'll be having some time for the lab also, but anyway, please like note this lab URL. So any doubts you have till whatever we have seen, please let me know. I'll try to like clarify it.
Thank you so much, sir. Your session gave us inquisitive minds fodder for the day. If the participants have any doubt or query related to the topic, they may ask through chat window or can unmute their mic and ask in person.
Yeah. So if you have any doubt, then please let me know. Oh, thank you, Professor. Thank you so much. I'll type my email also here that anytime you have any doubt, you please let me know. We can do any collaboration. Oh, thank you, Professor.
Sir has shared his mail ID in chat. You may note and further you may question.
Okay. So there is a question that what is the scope for research in the AutoKeras? So my like simple suggestion is like AutoKeras is just a tool to like perform the AutoML, but there are many other techniques which are related to the AutoML. So my suggestion is please don't focus on any particular tool, but please focus on the technology behind it. This neural network optimization and fine tuning, model optimization, model compression, this has a really good usage in the public also, in the real world. So I will recommend that you please work it in the research level. So please don't do any research in the tools, please. Maybe there is a better tool than the AutoKeras.
Any more questions? Okay, we are done with our question answer round. Now I would like to invite Dr. Dinesh Jain, Associate Professor, IT Department, to summarize this session and propose a vote of thanks. Over to you, Dinesh, sir.
Okay. Am I audible, Gaurav?
Yes, sir. You are audible.
Okay. Thank you. Thank you, sir, for sharing the valuable information on the topic of deep neural network optimization and tuning. Sir has started with the deep learning and model optimization, weight and bias, life cycle of machine learning, deep learning, training versus inference, model training, and how image proceed through the facial expression or facial apps like Prisma, FaceApp in cloud. Sir has also focused on AlexNet, a huge neural network model pruning in human brain and it deep insight on pruning concept and its different types of criteria and its different types. Sir also covered different types of activation function like linear, sigmoid, 10H, ReLU, magnitude based methods, AlexNet, weight pruning, weight matrix, factorization, truncated SBD, quantization, student teacher network, AutoCara, and so many topics has covered by the sir. Thank you, sir, for providing such valuable information. Definitely, we will apply this knowledge to solve the real life problem for the betterment of the society. So, on behalf of the Department of CSE, I feel privileged to express my sincere vote of thanks to Acropolis Management for providing me opportunity, and I would like heartfelt thanks to our distinguished speaker Dr. Sridhar Swaminathan, Assistant Professor, Vanity University, for enlightening us through his excellent presentation and deployment with live example to solve the real life problem and making this STTP interesting and meaningful. Thank you, sir, and hope for this association in future for such event. Thank you, sir. I would like also heartfelt gratitude to all the faculty and participants for listening questionfully and make this session successfully. Thank you all. Over to you, Gaurav, sir.
Thank you, Dinesh sir. Thank you, Sridhar sir, for such an informative session. Thank you very much.
Thank you, Gaurav sir, and very happy to see Dr. Dinesh Jain after a long time. Last time we met in the Acropolis, so I'm looking forward to come to the campus again.
Yeah, yeah, it's my pleasure.
Okay, sir. Thank you, sir. Bye bye. So thank you all, professors, and a really great time. I'm very happy. Thank you.
Okay, thank you. Kamal sir, shall we conclude? Praveen sir?
हाँ गौरव.
Okay, sir, shall we end the session?
Please share the link for the feedback and.
Yes, yes. Okay, participants, the link for the feedback for session 3 has been shared in chat. Now, this is the formal ending of day 3. Hope you all are benefited with today's session. Let's meet tomorrow with fresh energy, sharp at 10:30 a.m. Good day, everyone.